Okay, hi, good evening, everyone. Am I audible?
Yeah, for sure. So,
Yes,
good
sir.
evening, sir.
Yeah,
Okay,
good evening, sir.
thanks. Yeah, good evening. Okay, you can just log in on the Replit team. Uh, I've released the 4 problems today. I hope that you know about this Replit team.
Yes, sir.
Yes,
Please
sir.
share the link.
Okay, so 1 second. Yeah, those who have not joined this Replit team yet, they can click on this link and join the team. So every week we will use the same Replit team, and you can just open the team during the live session, and you can start. Okay, so just open the team now. You can see that week 2 problems are also visible. If not visible, just refresh the page. Okay, before starting the session, if anyone have any query related to the week 2.
Yes, sir. Actually, I was getting the insertion shot. So, there was a second method for insertion shot
Mm-hmm.
that was using recursion,
Mm-hmm.
and I faced quite difficulty in understanding that.
Yeah, that actually recursive method is also difficult to understand.
Yeah, sir.
Uh, yeah, so but why this is required? Anyway, it will
Only for understanding purpose. Yeah.
yeah, only for understanding it is fine. Otherwise, it will increase the complexity
Okay.
because we are not saving any time when we are using recursive in the insertion sort.
Okay, sir.
Okay, but still we can discuss if you have any implementation. Then you can share with us, and then we can discuss during the session.
Okay.
Yeah, Yuvraj, go ahead.
Sir, I have a doubt, like a question, sir.
Which question?
Why recursive calls? Well, like my doubt. I
Ha
have
ha
doubt
ha.
once.
Yeah, just go ahead.
Why recursive calls and returns are expensive?
Yeah, actually, some extra work is required in the backend. Some stack. If you know the stack terms, do you know stack? What is stack?
Yes, sir. A little bit I know,
Yeah,
not
actually,
much.
this stack will introduce in the week 3, and
Yes.
when we call the second, what is the recursion means? Actually, we call the same function again and again. Okay, so when we leave the one stage of the function and we call the same function again, so the reference of the stage when we leave actually from any function, that information actually stored in the stack. So one internal stacks is used to store the reference where we actually leave uh, the function, which is actually just using the which we are using the call, actually recursive call. Okay, so we leave that point and we just call the second function. Then again, we repeatedly call the same function, and we store the reference where from we actually are coming in the new function. So that information actually is stored in the stacks, and at the time of return, that return value is actually returned at that place. So that extra work is required in the recursion method. So that extra cost, if we are performing something extra during the program, so that definitely it is costly. Okay, so once the week 3 stack will introduce, so then we can discuss in this things in the detail, because you have to understand the stacks implementation also before understanding the recursion backend things.
Oh, okay, sir. But the
Okay.
main reason is like stack only, right?
Yeah, stack these things.
Okay, sir. Thank you.
Okay. Any other person? Okay. So, as you know that in week 2 we have started this time complexity things, and we have learned some sorting algorithms and searching algorithms. Okay. Now the question is also based on this complexity. So now today the live coding problems are also some problems are also based on this efficiency. So on the Replit, actually, let me share my screen and just show you. Okay. So we will discuss today's problem, and I have also released these problems on the portal itself. Okay, but we will solve all these problems on the Replit team. Why I have released during the live coding? Because this efficiency things actually cannot be validated on the Replit team, but on the portal we can check this thing. Okay, so for live coding problem number 1. Okay, so week 2 live coding problem number 1. So in the problem statement you can see that some information is also given about the efficiency of the solution. Okay, so write an efficient solution of log n complexity. So if this statement is written in the problem statement, that means you should write the code which actually should complete in log n time, in log n steps. Otherwise, you can also write very straightforward code for this problem, and the output will be correct, but the time will be large compared to this log n. Okay, so let's comes to the Replit team now and discuss the problem statement. So all of you just open the Replit team, and week 2 live coding problems are released, and you can start the problem number 1. So what is the first problem? Write a function find peak, okay, and one L. This is the parameter that accept a list L of n distinct elements. Okay, so all the elements, all the values inside the list are actually distinct, and returns the peak element of the list. Return the peak element of the list. Peak means maximum element of the list. A list element is a peak if it is greater than its neighbor. For corner elements, we need to consider only one neighbors. Write a solution of log n complexity. Consider that there is only one peak is in the list n. Okay, so that means we have one list. You can see the sample test case, and here you can see 5, 10, 20, 15. So what is the maximum element inside this list? Okay, and inside the question one condition is given that there is only one peak in the list. Okay, so now you can think about that, what type of inputs are possible which satisfy this constraint, and now that how you can solve this problem in log n time. I hope problem is clear. Basically we are finding out the maximum element in the list, but list have some constraint, and this maximum element we have to find out in log n time. Otherwise you can directly return the max of list. That answer will be correct, but time complexity will not matched. Okay, for some small test case, the code will pass the test case actually on the portal itself. Let me just show the same example. uh, yeah, okay, so this is the problem on the portal, same problem. Now if we write the very basic code for this, so what we can write, we can simply write the definition of function find peak. Okay, so find peak, and we are getting list L, and we can directly return max of L. Okay, so this function will return the correct solution, but here the efficiency is required in the problem statement. So, what is the complexity of this solution? Can anyone tell me? If you have already learned the content of week 2, so now you have some idea. If we are just using this max, how much time it will take?
N.
We go for
N. Yeah, big of N, correct. Because the max, finding the maximum of the list where the list is not sorted. Okay, so definitely the elements will be compared by one, and then we can find out the maximum element in order of n time. Okay, if list is sorted, then we can directly return the last element in a constant time, but here list is not sorted. Okay, so now just I've just run this code. 1 second. Where is the test? Oh, I think it's still this is not resolved. Oh. So this is one portal issue. Actually, test case are actually very big. So this page is totally distorted. So now you can see when I run this code, 2 test cases are passed. Okay, so these small test cases are passed because here the time required for these small test cases is very low, very small. So that actually not compared in log n or this end times in the portal. When we just give the large input, so we can compare the time of the code which have log n complexity and other code which have n complexity. Then it can be easily compared. So because of that, public test cases are passed, but these two large test cases are not passed. Okay. So now just think about that, how you can write the log n complexity code for this. Anyone have any logic?
I think by merge sort.
Merge sort. Okay, so tell me what is the complexity of merge sort?
N log n.
N log n, but we are asking that log n time.
Okay.
Okay, so n log n is larger than log n. Any other?
Binary sort.
Yeah, definitely. Binary search concept we can use. Now just figure out, we cannot directly use as it is binary search. We have to modify a little bit. Okay, at any time, if our question, if we are writing some solution code for the problem where we are finding something, and solution is required log n time, so definitely you can think about that this binary search concept. Okay, so in binary search concept means every steps we have to discard half of the input size, then we can achieve the solution in log n time. Okay, if we have n elements, the next stage the element should be n by 2, then n by 4. In that way we can just reach to the solution in log n steps. Okay, so in the problem which we are asking that log n time, you can think about the binary search concept. Now think that here how you can apply the binary search.
Sir, but for binary search, array has to be sorted. Here we are given an unsorted array.
Yeah, so
So
can you just figure out the pattern, because the question is saying that only one peak is there. Just take some examples, just take some think about some input where the one peak is possible, one maximum is possible in the list. And what is the definition of maximum? If the both neighbors are smaller than that number, and otherwise if the max or the other condition is that if maximum element is either coming on the first element or last element. These are the condition of the peak element.
So the test run and submit buttons are not visible on the portal.
Yeah, so actually the here test case are actually very large. So this is the problem with the portal. I've already reported this problem into the ops team, but you have to just move the page on the right side by the horizontal cursor. Okay, now you can see this test case, test and
Okay, sir.
submit. Okay,
Sir, also I'm assuming that the inbuilt functions are not allowed.
but what inbuilt function you can use here?
The max one, right?
So that is it is not working, no?
Sir, on Replit, it's working.
Because of that I'm saying that
Yeah.
Replit we are not testing the complexity because there's no way to check the complexity on the Replit.
Okay, sir.
Okay, so Replit on the Replit you may pass the test case by this function, but that is actually not a big login solution. Okay, so just try to figure out the login solution for this. Anyone have any idea?
Bubble sort.
No. Bubble sort is n square. And sorting, we are searching something. Why are you thinking sorting?
Sir, we can do it this way, like we have to take a for loop from the length of the list,
Hmm.
and if the position is 0, then we just compare with the next element. If the position is last, then we just compare with the before element. Otherwise, using the if condition, we can compare before and after, and if it is greater, then we will replace it with peak. I just implemented it. Should I share the screen?
Okay. 1 second. Or you have implemented on Replit?
Yeah, Replit.
Okay, 1 second. Let me share your.
I'll submit. I have not submitted it.
No, not Rola. I can see your code. What's your name?
Varun.
Varun. Yes.
Oh, but I think 3 out of 5 test cases are passed. Only
No,
3
Replit,
are.
maybe your solution will pass the code. But
Okay.
so this is your code, na?
Yes.
Let me see. Yeah. So find peak. Still, so you are running one this loop.
Yes.
Okay, I in range len of L. That means if we have n element inside the list, you are using this loop. Can you tell
Yeah.
me how you are just achieving log n time using this loop?
Yeah, sir, it will be not login, I guess.
No, it is not login.
Yes,
Yeah,
it
it
is
is
not
n.
log n. Okay, this is n.
It is n.
So
N.
instead of this solution for n, you can directly return the max. That is
Right.
also n. Okay.
Got it. Yes, sir. Got it.
So before starting to writing the code, just think about the input list pattern, and then think how you can apply the binary search. I've already told you binary search concept is required for this, but we have to modify a little bit. Okay. So first thing, according to the question, I'm taking some input. Okay. So according to the question, if I am writing like this, 1, 2, 3, 4, 5, 6, 7. Okay. So this one input is possible in that way. Okay, so here this is the peak element, or if I draw this, so we can say that our sequence is like this. This is the peak element. Okay, here this is the smallest element and this is the largest element. Okay, so this is the max and this is the min. Okay, so now this is the peak, and another possibility is just opposite, reverse. Okay, so 7, 5, 2, 1, like this. Okay, so here first element is the maximum, so that means the first is
Excuse
the
me,
peak.
sir.
Yes.
Sir, actually, I got an idea to solve this, but I was not able to implement that in the code.
Just tell me the idea.
Sir, basically, first thing we need to check if the list is sorted or not. If it is sorted, then we directly
Okay, but
the last element.
this is
Otherwise, what we are doing, we are dividing it by two, and we are checking the that element is less than is that element is greater than the previous one and the after one, and we are
no,
continuously
surprise,
dividing by two.
surprise.
Yes, sir. Yes, sir.
Can you tell me how you are checking that list is sorted? And how much time is required to check this?
No, sir, I don't know actually.
So still, if you want to check that list is sorted, you have to traverse all the list one by
Okay.
one. You have to compare that
Yeah, yeah,
previous
sir.
element
And
is smaller than, okay, in
yeah,
that
yeah,
way.
and
Still, then you will get n time.
okay,
Yeah,
okay,
and in that case, it is n.
Yeah. Okay, if you are performing any one operation of the n, the overall complexity will become n.
okay, okay.
Okay, so now here, so this is the second possibility, first possibility, second possibility of input. Another possibility according to the problem is, I'm just drawing the diagram here. So this is the type, like this. Okay, so here this is the point, this is, and peak is coming in between. Okay, so one condition, if peak is coming at the last point, second condition, if peak is coming at the first point, and another third condition is if peak element is coming in between first and last. So these three patterns are possible. Okay, so third we can like write like this. So one, all elements are distinct. Okay, so we cannot repeat the elements. So like 1 3 and 5 7, and then 6 4 and 2, like this. Okay, so this is also one possibility.
Excuse me, sir.
Yes, Siddharth.
Uh, Sir, can I share that Replit link because I
Okay,
joined
okay,
late
you're not joined
earlier.
was okay. So did you join the previous session, previous live coding? Okay, one
Sir, it is
second.
already sent, I
No, sir.
guess, in the
Last session
chat
I was
box.
not able to join this my first session.
Oh yeah,
It is already
chat is
Thank
there.
you.
Yeah.
Thank you,
Huh.
Varun.
Yeah, just click on this link and you will. Okay, so according to the problem statements, three possibility are there, and this is the pattern of input. It is clear. Any other possibility?
This one.
Okay, so this is satisfying the peak definition. This is satisfying, and this is satisfying. Here the this one is lower. Both neighbors are smaller than this. Then this is a peak. And question
Sir,
is also saying that more than
sir,
one peak are not there. Yes.
sir, there can be one more possibility.
Yeah. Can
Starting
you tell
from
me?
greatest value,
Huh?
then in middle, lowest, then this can also increase. Starting from
No.
greatest
Can
value,
you just tell me any example?
like 7 5 3 1
Seven, five,
6 4
three, one,
6 4
6,
2 4
4,
2.
2. Yeah. So in this case, according to the problem statement, this is also max and this is also max. Correct?
7 will be the peak according to the problem statement in this question.
Huh. This is also, and this is also satisfying the condition.
Yeah,
Na?
yeah,
So
sir, yeah.
both neighbors are smaller. So now the
Sir,
two peaks are there.
one condition can be there if all the elements are same. We are skipping that.
But that
But the
cons
elements are distinct. All the elements are distinct here.
yeah.
Okay, okay, okay. Okay.
Okay. So
But it is
all
said
the,
there is only one peak.
yeah, there is, and this is also given in the question. Consider that there is only one peak is in the list. Okay. So in this
So this
case, yes.
we should focus on the mid element.
Why mate?
I think we have to half and half and half.
Huh. Now, so
Binary search.
yes. So after identify the pattern, so only these three are there. Okay. So this is not the correct valid input according to the problem. So only three possibility are there. This one, and this one. Yeah, Pratik.
Sir, I have done it on Replit. I don't know the complexity, but I've got all the test cases passed.
No, can you check your solution on the portal?
Okay, sure. I'll.
Okay. Otherwise, we will also check your solution.
Okay.
Okay, but before that, you can also check. Okay, so this is fine. Now here one pattern is there. Now you can identify that for this constraint. So this is the pattern. Either the list will in increasing order and last maximum element is at the last position. Either list is in the decreasing order. So max peak is at the first place, or either the list is increasing at some point till some point and then after that decreasing. Okay, so now some pattern is there in the elements. So here the order is there. So this is sorted, this is sorted, this is sorted half in increasing and then decreasing. Now you can think about the binary search concept here. These two condition you can directly check in the constant time operation. Okay, these two condition you can directly check. First you can check if last element of the list is greater than the second last element of the list. Okay, just check this condition. The last element of the list is greater than equal to greater than the second last element of the list. If this is true, directly return this solution. This is the pre. Okay, similar for this second condition, you can directly return the answer in constant time. Just check first element is greater than the second element, you will get the peak. But for this case, you have to apply the binary search things like finding the mid. And what is the condition? Okay, so what is the condition to identify the peak? If peak is not exist in the first place and last place.
Sir, the ith element must be greater than the I minus 1 and I plus
Yes.
1.
Yes, correct. Okay, so then we can directly return the solution. If this condition is not true, then how we will decide that which part we need to process further and which part we have to discard. Suppose if in this list is given like this, so 1 comma 7 and then 6 5 3 2 like this. Okay, here the peak is 7. Okay, so this is like this. Okay, so this 1 7. Okay, in that way. So now if you are checking the mid element, suppose you are getting mid element as 5. Okay, now you are getting the condition like this. The element which is coming before this 5 is greater and which is coming on the right it is smaller. So like sequence is following in this process, decreasing. Can you identify that which side the peak will come based on this current condition of the mid?
Left.
This becomes a second case.
Here actually for the binary search concept we have to discard half part. Okay, so we have to identify the condition. So first condition, if both neighbors are smaller, then we can directly return this is the answer. But otherwise if both neighbors are not smaller, then we have to identify that which part we have to discard and which part we have to process further. Okay, so what is the possible condition for this? How we can identify this? So there are two conditions we can achieve during this check, mid element check. So we can just compare the neighbors element. Okay, so suppose we are getting the middle element, so this is the LM. Okay, this LM, if the element is look like this, so L M minus 1. Okay, and this type. Okay, L M plus 1. Okay, if this sequence is coming, okay, so we are checking for this middle element and we are comparing by the neighbors. If we are getting this order, that means decreasing order. So definitely peak element will come on this left side because this side the elements are decreasing. Okay, this side elements are decreasing. So definitely peak element will come on the left side. So you can directly discard this right part. For next process, you need to check only this left part only. Okay, and similar to the another condition, if you are getting this situation, so LM like this, so LM minus 1 and this L M plus 1. Okay. Okay, so here you can find that when we are comparing middle element with the neighbors, we are getting this order. That means elements are increasing into the right. Okay, so element, the peak element, so will where will the peak element will exist? On the right side, because the elements are increasing on the right side. Okay, in that case you can discard the left part.
Sir, are we progressing on the more login? Are we progressing on the login?
Yes, definitely, because we are checking directly middle element, we are comparing with neighbors. Based on that we are deciding that which part we have to discard. So definitely from the mid element we will discard half part, either the left, either the or the right.
Is it not n by 2? The complexity is not
No, 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 no,
n by 2?
no, no.
No?
Every time we will discard half of the list. So initially suppose we have 8 element, the second step we will receive only 4 element, then with 2 and then 1. Only 4 steps we are coming.
Yeah, sir, the thing that you said is okay, but sir, one thing, if
Mhm.
what if the LM plus 2 element is much more greater than LM minus 1?
Much more means
It is greater than L. Sir,
what condition you are saying that?
if
Can you tell me?
LM plus 2,
M plus 2.
no, no,
Okay.
no, no,
Hmm.
inside,
Okay, okay, one
write
second.
it inside, at LM,
No, sir. Suppose the number 7 is in the last, how you will work out?
M plus 2 is
This
greater than
example.
LM minus 1.
Greater than
In the
L.
first case, you discarded the right part, and you took the left part, right? But if we have this
No,
condition,
why you are comparing? Why you are comparing this LM plus 2 to M minus 1?
because sir, if we are discarding that part, that we are not using that part, right? So we will get a wrong answer.
No,
No,
which
sir. In
part?
this example, no, no. In this example, you just write down this 7 number in the last, sir.
Yeah, this one.
No,
Yeah,
7.
so that things we have to care. We have keep this mind when we are discarding. So this element, middle element, can also be an answer.
No, 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 no.
No, no.
If 7 is in the last,
Why 7 is lost?
no, no. In the suppose in the input, if the numbers are like that.
So what input you want to take? Just tell me.
No,
And
this fourth exam, fourth number on the
yes. So here actually this input is not possible for this problem, which actually in the problem statement it is given that 2 peaks are not possible.
Okay. No,
Okay, so
in the
this is
last.
not a valid input.
Sorry,
No,
can you
no,
go back to that condition that you were writing, the two conditions?
no,
Yes.
no, in this example, sir, the
Sir, can you write
number
one list
7.
that I'll tell you?
One second. Yeah, you are talking about this.
Oh, yes, sir. 165
Okay.
5327. If you write.
Okay. 17653.
No. 7 is no 1653.
Okay. 16. Then
5327.
5327. But
Then
here this is also not a valid input.
why, sir?
There is two peak. There is two
There's
peaks.
2
Sir,
peak
yes.
actually. This is also a
Yes.
peak. This is also a peak. This type of input is not possible for the problem, which is mentioned in the question. Okay, 2 peaks are not possible.
These are the different numbers. No? 6 and 7 are different numbers. No?
Yeah, 2 are different number, but in the problem statement it is given that only 1 peak is there.
Sir, I've submitted.
No, peak means the maximum number.
No? Maximum number, but definition is also given. What is the peak actually? Okay, so here peak definition, if you read the question, so a list element is a peak if it is greater than its neighbors. Okay.
Okay.
So this is the one definition. And for corner elements, we need to consider only one neighbor. Okay, so if we are checking for the corner elements, then we will only compare the one neighbors.
Okay.
Okay, so this is the condition of peak. And this is also mentioned that consider that there is only one peak in the list.
Okay.
Okay, so that input is not valid. Yeah, Bikram?
Yes, sir, I've submitted the code. And
Okay.
it is passed all the
Portal?
test cases.
Portal?
Yeah, in the portal as
well. Okay. Then I will check your code. Yeah, any other code running? Sorry, who is this?
Sir, I have
Yes.
submitted on the portal, but it is not showing. It is just showing submission successful. All test cases passed, but it is not showing the what order of.
Okay. No, it will not show the order of the. If all test cases are passed, that means your code is efficient code. Okay, so can you just tell me your replit ID? I will check your code. Any other query
Sir,
before?
in the portal, I read the week two problems. Only week one problems are there.
Sorry, can you repeat? Yeah, Subramaniam.
In the portal, I have only week one problems. Week two problems are not there. I am doing only in replit.
No, portal. You can just refresh the portal. All the problems are there.
Can I share the screen where I am going wrong?
So just first check my screen there. Yeah. Just inside the live coding tab. Okay. Live coding. You can see. Just go first. Week one complete. Now week two is start. Week two live coding one. Week two live coding two.
No,
Week two live.
I have only 8 problems are there in that one.
Can you refresh your page?
Refresh the page. Okay.
Yeah. So now I have given the condition to check. So please, all of you, just try to write the code and apply this logic.
Okay, sir.
Okay. If you have any doubt, then you can ask. So similar problem, I think you have also in the graded assignments where the list is rotated. Okay. So if sorted list is rotated k number of times where we don't know what is the k value, and can you think that how you can apply the binary search logic? That problem. So this is also a similar problems. Uh, okay, so I'm opening the Replit team. One more thing. This is a very important thing. When you're writing the binary search implementation, please do not use slicing. This is the page of who's written this name of it.
Sir, if we use this slicing, will it not will it still give
Yeah, yeah, it will return actually the time complexity will increase. It will become order of n time solution. Okay, so what is this actually slicing? A slicing operation, what is it is doing? It is creating a new list and it is copying that portion which we are passing inside the slice. Okay, that portion actually it is copying all the elements one by one into a new list. So internally it is taking n steps. If we are passing suppose n by 2 element, okay, so if suppose if we consider a large input, we have 1,000 elements. Okay, so 1,000 elements, if we are creating the new list using slicing, okay, so that means 500 step is still required to copying the half of the element into a second list. Okay, so that because of that, this slicing is actually a expensive operation and it actually takes order of n time.
Please explain it again. What does slicing does?
Slicing, what actually slicing? When we use slicing, what happened? So when we use slicing, actually it creates a new list. Okay, and if we are passing the value 0 to mid, that means half of the element n by 2 of the elements is actually copying to the new list one by one. It will copying to the new list.
Okay.
Okay, so n by 2 operation is required in this process. So n by 2 is equal to approx equal to order of n time complexity. Okay,
Okay.
and log n is n log n and n by 2 is very different. So difference
So
is like
that means the n times it's approximately it's on. Like if
yeah
you
on yeah. Okay, so n by 2 we consider as the order of n time. So do not use this slicing in your implementation when we are asking that to write the code of the log n complexity. Just try to implement the binary search concept without slicing. You can use this loop, simple while loop or for loop. and using the recursion method also, but without slicing. Okay, just pass the parameter of the input list. Okay, so how many of you have solved this?
Yes.
Okay, so let me check. Okay, so 5 submission I have received. Uh, who want to explain the solution? Anyone of you? Those who have completed, please. Some name is coming by the roll number. Bikram. Anyone, those who have completed the problem number 1, want to explain your code?
Yes, sir.
Who is this?
Vikram.
Bikram. Okay. Bikram, I'm opening. Bikram Negi.
Yes. So, sir.
Yeah, this is the code
Implemented a
actually.
binary.
Binary search and slicing is not there. Yeah, that is okay. Fine. Okay, can you just explain line by line?
So, first line you get the low index and the high index of the list. Then we iterate up until they are equal, or we find uh, mm, the one that we are trying to find, the peak.
Okay.
So first the first condition is for when the edge cases, basically when mid becomes the zeroth index or the last index. The
Okay,
first
so
if and elif.
this and else. This one. Okay, this first one.
Yeah, this one. And so if it is the zeroth index, then
No. So one second. Here actually, what you are doing, if mid.
yeah,
Is
if mid index, then we are
okay.
checking the next element.
Okay, that means if you are reaching, so if you are calculating mid and you are getting the first index as in mid, then only 2 elements are there to compare.
Yes.
If for this mid is greater than with the second
Then that
element,
is
then
the peak.
answer, and otherwise second. Yeah, it is also fine.
Yeah. Otherwise, the second one is the peak.
Yes,
Yeah.
yes, correct.
In the next case, we are targeting the second edge case, which is the
This is
final
if last element.
Last element.
Okay.
And then only 2 are left, last and second last. We check those.
And else part, that is
else
the
part is the main part. Yeah. The
okay,
condition is peak, that we know the condition greater than the left and the right.
Okay. So is peak okay? So this two condition, if it both are increasing, decreasing. Okay,
So if
okay,
the
okay.
mid is greater than the previous and the next one.
Okay. So this is the condition to find neighbors things. Both are smaller. So if this is true, then you're returning this condition. Okay, so else part, you're checking two condition. If mid is smaller than mid plus one. Okay, so elements are increasing that side on the right side. So you are just setting low equal to mid plus one.
Yes.
Okay, fine. Otherwise, high equal to mid minus one. Yeah, that solution is also yeah, fine. And I hope this is passing the test case on the portal.
Yes.
Okay, fine. I hope the others approach is clear.
Yeah, sir.
Could you please, sir, please explain, sir? Could you explain again, sir? I'm not.
Yeah, this code.
Yes, sir. Yeah, you can explain any code solution. I will.
Okay. Otherwise, I am writing the another code. Okay.
Yes, sir. Yes, sir. Then it's good.
One second. Okay, so this is the problem, actually find peak. Okay, so we will write the definition function. So sorry, function find, and taking the input L, then we will use the base case. Okay, first element is greater than the second element. Okay, so then it will become a peak element. If last element is greater than the second last element, it is now that is actually peak. Otherwise, we will just use the binary search things. We will find check the mid position, and we will return the answer. So we can directly apply this condition. So if we can directly check the base case. So suppose we can write L 0. Okay, L0 is greater than L1. Right? And we can return the answer L0. L if L, okay, so we can write like this -1. If it is greater than L -2. Okay, so this is the second case. We will return L -1. Okay. And third condition is else. Now we will use the that things, binary search things, and here we will first set the low and high things. Okay, so I'm just setting this L low equal to 0 and high equal to len of L -1. Okay, so this is the first index and last index. Now we will calculate the mid equal to low plus
I minus low.
I minus low, or we can directly write this in
By divided by 2. Yeah.
Divided by 2. Now this is the first calculation of the mid element.
So it
Now
should
we
be
will
double hash, double divide.
Flow division.
Yeah, sorry. Yeah, correct. Flow
Yeah,
division.
it is. Yeah.
Okay. Now we'll take the condition. What condition we can write here? While mid. What we can write here? To stop actually. Or anyway,
is greater
we
than
can
equal to 3.
Or we can write like this way, because anyway we will find out the answer in between. So while true. Okay. And what we can check, we can simply compare the element. If list of mid -1. Okay, so mid this element, so mid
Sir,
-1.
is it also correct that while mid is greater than 2?
No, mid is greater than 2 is not okay. Why mid is greater than 2? We can write in that way if high minus low is greater than 0. In that way.
Sir, but if we are having, like, we need to have minimum of 3 elements, right? To check.
No, mid value we can also get at the, so our mid can also be reached at the 0 index. Okay, or it may be reached at the last index during the process. So we cannot assign the condition for the mid. We can write in that way if high minus low is greater than 0. Okay, so otherwise we can simply, we will get answer because anyway we will always have one maximum element in between. If the initial two conditions are not satisfied, then that means the max element will always come at the in between. So we will get the answer.
Okay.
Okay, so here while true, so we will running this loop and we will return the answer in between. Okay, so that our function will stop. Actually, this loop will stop. So So this is the condition if this is smaller than L mid and the remaining the right side element is also smaller than this. So L
Mid plus 1. Okay.
mid plus 1. Okay, so both neighbors we are comparing. If this condition is true, we can return the solution L mid.
Mid.
Okay. Otherwise, L if we can check the condition if L. So we will take the above elements. Yeah. Okay, but the condition if the elements are suppose increasing. Okay, so in that way sequence elements are increasing on the right side. Okay, so that means peak element will come onto the right side, so we can discard in this case the lower part, left part. So that means we can set our low value. So
Sir,
low.
can you explain this logic again? Means in the diagram, because I didn't get the
Okay,
first two
one
conditions.
second.
I got it. But these...
Mid plus 1. So in the diagram, suppose in this process. So I'm just explaining with the diagram. Okay, so the middle condition. So our order is look like this. Okay, correct. Suppose here in this diagram you are thinking that this is the mid position. Suppose we are getting this mid position, this point. Okay, and we are getting the neighbors on this point. Okay, so this is M, and this is M plus 1, and this is M minus 1. Okay, now you can see that the elements order, what the element order is increasing order. Okay, so the left neighbor is smaller and right neighbors is greater. So that means if we are getting this order, increasing order, so peak element will come after this middle point, not the before this middle point. So we can discard the this part. We can discard and we can search the right part. Okay, and in some position if we are getting this point as a mid, okay, and here and this is mid and this is M minus 1 and this is M plus 1. Okay, now the order is like this. Okay, it is.
We can discard the left part.
In this case that means sorry. Oh, okay, so not this. This. Okay, elements are decreasing this side. Okay, so greater element will come on this left part, not the right part. So we can discard right part. Okay, we can discard this part and we can search only this side. Okay, so because based on that we have decided two condition in the code. So this is the condition when our elements will come, max element will come onto the right side. Okay, because the first neighbors, actually left neighbors is smaller than the mid element and the right neighbors is greater than the mid element. So the sequence is increasing to the right. So max element will come on the right side, not the left side. So we can discard the mid left part. So because of that, we are just assigning this low equal to mid plus 1. Okay. Now our next area to search is that will start from mid plus 1 point to high. Okay, right part. And other condition, else part, we will just continue with the left part and discard the right part. So just opposite remaining condition is that. So we can directly write the condition for this high equal to so mid minus 1. Okay. So in this process, at any time we will find out the output and then we will get the solution in log n time. So we can test the run here.
Sir, why you write high equal to mid minus 1? Can you explain this? I didn't realize.
1 second. Yeah, some test cases are failed. Let me check what condition we have missed. Okay.
So please explain the time complexity.
Yeah, time complexity I will come on that. Okay, low plus high.
So it's scanning every single element anyways, right? What is the difference between linear one?
Why it is scanning every element?
No, if if it didn't
Yeah, sir.
find on the left side.
We need to divide the mid part in the while loop, I guess. After
Oh,
the
okay, okay, okay. Yeah, that, yeah, correct, sir. Hmm. So first loop we are getting this mid, and if we are not getting this, we have to again update this. No, no, we are setting this mid, na? Okay, 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 got it.
And it's not sorted here, right? It's if it is sorted, it will work.
Yeah, passed. Okay, now what is your question?
Yes, time complexity between this one and linear one. It's not
Yeah.
scanned.
So can you tell me, are we going linear in this code?
This is not linear,
This is
but I
not
think
linear.
it's scanning every single element, just
No, no,
like it.
no, no. It will not scan the every elements.
Okay.
Just assume so can you check, this is the constant operation first. Okay, we are simply comparing first element and second element. Then
Yes.
this is the another constant operation, we are comparing last element and second last element. After
Yes.
that we are just assigning that low index equal to 0 and high index equal to last index.
Yes.
Okay, now in this loop, while loop, we are calculating the middle index directly.
Yeah.
Okay, and then we, by using this simple expression, and then we are comparing the neighbors of the middles. Okay, middle element, left element and right element. If this condition is true, we are returning the solution directly. Okay,
Yes.
otherwise if this condition is true, we are setting low equal to mid plus 1. That means complete half part of the list is discarded, which is coming on the left.
So there is only one element, right?
No,
One
there,
element in the list.
no, no, no,
We
no.
are looking for.
Okay, just explain this. One second. This is the code. What have actually? Okay, suppose we have. I'm taking 8 element. Okay, so what?
We are taking 8 elements, but we have to find one element,
Yeah, we are
and it is
searching
not
one element. Yeah,
sorted.
we are searching one element, but every time we are discarding half of the element without looking the elements.
If there is no element in the list, then it will be the last element,
If there
highest
is
element.
no, 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 sorry. If there is no element in the list means,
If, there must be one highest element in the list, right?
yes.
If we don't find any number
No, no, no.
up
In
to
this
the
case, you will always find the maximum element. Can you tell me the case where the output is not there?
so show some examples from
Huh.
eating with the 8 elements. I will tell.
Okay, so I'm writing so two condition which I mentioned that the one condition is like this 1, 3, 5, 7, and 9 like this. Okay, so this is handled by the first condition. Okay, no, no, not first, second condition. Okay, when we are comparing these two elements. Okay, if 9 is greater than 7, this is the peak. Okay, if another condition when we have the sequence like 9, 8, 6, 4, 2. Okay, so when we are comparing first and second element, if first element is greater than second element, this is the answer. Then this is also a constant operation. Then we are checking this else part. What we are doing in this else part, suppose this two condition are not satisfied, then another condition is then maximum element is coming in between. So the case is like look like this. So 1, 3, 9, and 8, 7, 6, 5, 2, like this. Okay, so here you can see that this is the this sequence is look like this. Okay, here what we will do, we are directly checking the mid element. So what is the index? 0, 1, 2, 3, 4, 5, 6, 7. This is the last index, 0 and 7. What we are doing, 0 plus 7, floor division 2. What we are getting? 3. Okay, so 3 index is for 8. Okay, Now in this sequence, when we are just checking that what sequence we are getting, this is smaller this side. Can you check? This is a middle element, and we are getting this condition true, else part condition true. In this case, we will discard this complete right part to check, and we will check only this side. So you can see that if we have n element, we are directly discarding the n by 2 element in the one step. Okay, we will never check this side. So n by 2 element is discarded. Now we need to
Sir,
check only this side.
sir,
How
it
do
is
you make this conclusion, sir?
Sorry?
How do you
sir,
make
it is possible that
how-
number can be there at right side also, discarded
So
glucose.
if we are getting situation like this, if middle element, the left element of the middle is smaller than this. Okay, so m minus 1, and right element of the middle element is greater than mid. Okay, so m plus 1. If we are getting this type of situation during the checking of mid, then definitely we can understand the max element will come onto the right side. Then we can discard this side completely. We will never check this side. So only the n by 2 element is remaining to check in the next step.
Sir, we check
Sir,
only the neighboring
sir,
not
it is not sorted, right? So
sir,
It
it
is
is not.
sorted. It is sorted.
Sir, like in the
They,
above.
Oh,
Sir,
Sir,
can I
suppose
say something? Hello,
in this, sir, 1 second, sir. In
sir.
this example
Sir,
only, if we
hello.
get 193,
sorry,
then
one by
what is the
one.
possibility, sir?
Sorry.
Same
One,
doubt that they are
one.
asking, but when I solved it in the notebook, then I understood whatever you are saying, and it is true because the condition is only one peak element can be there.
Yes.
That is why they are saying that cannot be true. I was also thinking like that, they are thinking,
So because of
but
that, I
try
said
to
that
do
the
it with the notebook. In the
only
notebook,
these
you will
three
get the
order
point.
are possible.
Yeah, sir. If there are more than one element, then the possibility can be there that there might be a
Yes.
element in the right side. You can
Yeah,
try
but
and do in the notebook also. They did the same thing and I understood then only. Otherwise, I was also facing the same problem.
okay. According to the problem statement, there two peaks are not possible. So if we are following this condition, only these three order are possible. So in
And
some
sir,
way, we have sorted input. Yeah, sorted
sir, they
pattern.
are saying like I can tell you. Could you please write the list, sir? I'll tell you one list,
Yes,
and
yes,
I think
okay.
their doubt will be solved. I also tried with this one
Okay.
comma 7 comma 6
1 comma 7 comma 6
comma 5
5
comma 3
hmm,
comma 8
hmm,
comma 2.
2. Yeah.
Sir, they want to say if if we are checking the middle condition, 6 is greater than 5 and greater than 3.
But
Okay.
sir, this is not
So
a
we will
valid.
discard the right part, but this list cannot be as per our questions because it is
Yes.
having two elements. So
Yeah,
it
This is
is
because
not
of
a
that,
valid list. No. This is not a valid list.
I mentioned
yeah.
this
That is what I
sample.
was saying.
Yeah, I mentioned this sample input already before in the during
Yes, sir.
the explanation. Okay, so this type of input. Okay, so this type you can think.
Yeah, sir.
Here we are
Definitely, you
just
are correct.
taking. Hmm. Okay, so this is the case where two peaks we are actually getting in this case.
But sir, if you remove
This
8,
one,
sir,
this
if
one.
you remove 8 from this,
Then it will be valid input for this problem. Then we will get
now,
the 7.
let's sir solve it, sir. Sir, if
Okay,
we are solving
7,
it,
6, 5, 3, 2. Okay, you are seeing this?
Yes.
Okay, now we have all, what is the index of 0, 1, 2, 3, 4, 5. Okay, now 0 plus 5 divided by 2, we are getting 2 index. Okay, so that means we are comparing this middle element first. Okay, now we are comparing the sequence between with the neighbors. So what sequence we are getting? We are getting order like this. Can you think?
Greater than.
Yes. So greater than means max element will come into the left side of this middle element. Okay. So because this side we are our elements are decreasing. Onto the right side, elements are decreasing. So max element cannot be come on this side. So we will discard this part completely, and next part we will check only this. So we will set our low equal to 0 and high equal to 1. Okay, so in this case when we have 1 and 7 only.
Excuse me, sir. Means hello.
Yeah, we will not make the confirmation until we complete the right side travel. No,
Sorry, can you repeat?
we will not make the conclusion that the peak is not there on the right side until we complete travel
No,
across.
no, no. We can conclude that
Why?
by
How?
We can
getting this
conclude. Can you
situation.
please give one example? Can you please give an example that you are saying?
Means
That peak will be also in the right side.
hello, hello, sir.
Eight. We can
Yes, sir.
insert eight somewhere.
Uh, means
Then that cannot be the case because there will be
for
two
this
peaks, 7
question,
and
just
8.
means visualize a triangle and that's it. Means that will be a best case to understand it.
Yeah. So this triangle things actually,
Means
which
visualize
I'm
a
just saying that.
triangle that will be the best
Huh.
case.
So in that case, okay. So
Means
I'm just 1 7. Okay. So this is the situation. Like, so this is the one element. This is 7, and now you can think that order is look like this: 6 5 3 2. So okay. So 6 5 3 and 2. So this is the order. So always, if first element is not max, last element is not max, you will always get this order: increasing, then decreasing. Okay, this is the
okay,
only
sir.
possible input
Okay, sir.
order:
And
increasing, then
yes,
decreasing. So some pattern is there. Then based on this pattern, you can apply the binary search and just check that if
But you are
find
assuming
out
that
the
it is a
localization.
sorted list, no? That's how the numbers are there, no? It's all
So no,
sorted.
we are not assuming. This is the conclusion
and
of the
one
based on the
and
problem statement. So in some way,
Sir, it is.
Sir,
Sir.
can
Sir,
you use
the case they are
unsort?
talking
and
is an
yes,
impossible
I
case.
also got it. And
With one peak element, it's an impossible
Sir.
case that they are talking. With one peak element, it cannot be possible that it is also having in the right side also 8. Try to put, if you are putting 8 in the right side, then there will be two peaks. You can see 7 will also be a peak and 8 will also be a peak of this. It cannot be a case. Try to do in a notebook, please.
take any example which you are
yes, sir,
just
he's right
thinking
because
that.
also solved
Okay.
now. Just
So
Sir, could I ask
yeah,
anything?
yeah, sure.
Sir, it is very difficult. Could you explain a simple code? And
So
I'm sure that there exists a simple code.
so I think which I just written. This is the simple code. What is this difficult in
Nah, it is
this?
too complicated. You explain 3 4 line. That's
Sir,
all, I
can I
think.
share mine?
Okay.
It is very simple and 4-line code.
Very
Okay.
nice. Please share.
But
Okay. What's your
okay,
name?
okay. Can I share?
No, no. 1 second. Tell Sonam.
Yes, sir.
Okay, let me open your Replit 1 second.
Not Replit, sir, on the portal, sir.
You are not using the Replit.
I'm using Replit also, sir, but I.
Just copy your code, portal code in the Replit, no? Then I will open your
Okay, sir. Okay.
Sonam, column number 1. So because of that, in the first session, I've mentioned that before writing the code, just figure out the things on the paper and pen. Okay, if some constraint are given, just read the problem statement carefully and follow that completely, and just check that what type of input is possible like that. Then you will get some idea of the pattern of. So binary search is not just only for the increasing order or decreasing order. Yes.
Sir,
Okay.
I can explain it, but I'm also taking help from someone. So.
Okay, no problem. Just first, where is your code? Actually, I'm waiting your code.
Okay, sir. You can check here on my week
No,
Replit on the Replit.
this is your Replit, Sonam Kumari 13.
Yes. 13.
Yeah, but code is not there.
Sir, I can write it on chat box.
Okay, just write in the chat.
Okay. And it is working on portal and replit both.
Let me check.
It is visible.
Yeah, I'm looking into this.
Like I defined the function find peak and
One second.
okay.
This one. Function name is not there. Okay, so this is your code.
Yes, sir.
Okay, so left plus right minus left, and mid is greater than. Okay, so left is and right 0 and len. If left is less than right, mid you are calculating directly, and if L mid is greater than L mid plus 1, you are getting right equal to mid.
Sir, I just accepted some random list, and on the basis of this, I had written this, and it is passed. It passed.
If it is handling all the cases, so definitely this is also correct. But your code is actually a login time code, correct? Okay, but I am just looking that if
Right.
any.
It is login time, yes, sir.
Yeah, this code is actually login time.
But this is the smaller code. It is beautiful one, sir.
But still you have to understand the case, all the case, how this code is actually handling all the cases.
Yes.
Okay, this is just not a small code is actually always good. Okay.
Yes, yes.
If you are not clear that how the all conditions are satisfied by this code.
Yes.
So Sonam, can you explain how this code is actually handling? Yes, Siddharth.
Sir, I'm taking a list 1, 3, 24, 10, anything randomly a list. Okay. Left is index 0 and right is index len minus 1. Len of L minus 1. And then
okay, one second.
Sir, I think this code it
So
assumes
please,
that the list is in ascending order. Something like that.
No, ascending will be fine. It will be fine. But second, so mid plus 1 mid element, and this mid is
Sir,
greater
it's
than.
also correct. It's also based on the same approach that you
Yeah.
were telling.
Yeah, this satisfying all the cases.
But it is on the same approach. If you look, it is converting from peak to right hand side.
Yeah.
The only difference is in this only one side we are checking, not with two elements we are checking. We are only checking with one element, and it is also correct. I checked it
Yes.
with a notebook.
Yeah, this is also correct.
with
Yeah.
the help of anyone. So that.
No, yeah, this is also handling the all the things, because if our list is already in sorted order, either in increasing, decreasing, or increasing then decreasing, in this case. Okay, so in that way you are finding the middle element, and then you are comparing middle to middle plus 1 next element. So anyway, so if order is increasing in this side, then you are setting, so here you are including this mid actually onto the right. Okay, because of that this is handled all the cases. You are not ignoring the middle element.
The middle is not compared with the previous element, no?
Here you are just actually after comparing the middle element, you are also considering the middle element into the left part. If you just set this -1, then you will find out some case, then your code will return the incorrect output. So as you mentioned, this left equal to mid plus 1. Why you did not set this mid -1? Sonam?
Yes, sir.
So in the else part, you set this left equal to mid plus 1. Why did not set here right equal to mid minus 1? Why you include the mid in this part?
Yeah.
Okay.
Okay, so because of that, this is handle the case.
Why don't we convert to mid -1 and run the code? Let's see what
If we convert this mid -1, then some case may be ignored.
Give it a try,
because
sir.
here we are just comparing the mid and mid plus one. Okay.
Okay.
So suppose if I am writing
We
this
are
mid
not
minus.
taking care of other parts.
So mid, if we are suppose if we are actually we are not checking the result before, we are simply comparing mid and mid plus one element. Okay, so in that case, if we ignore this mid here and based on this condition, so that mid is also possible in the output.
Sir, on the web portal, there was test cases including all the conditions. No, like wh- when you say why you are taking mid plus one, why not mid minus one. So on the web portal, there were several conditions. No.
Yeah, there are several conditions, but during the writing the code, here you have just ignore the mid. But why you include this mid in this side?
Sir, one thing can I ask?
Yes.
Sir, actually, when we are writing, if we are not writing mid minus one and we are directly writing mid, then we need to have one more division in the list. Is it correct? Then we are
No,
adding one more.
more division is fine. But is
Sir,
there any
but now it
chance?
will be it will be log n. Still, it will be log n.
Still it will be log n. So log n,
Oh.
if you are getting log n plus one, that is that we can ignore. Constant things we can ignore.
Okay,
Okay.
sir. Okay, thank you, sir.
So, but in this case,
Can you run
yeah.
the code, sir? Because you edited the code, no? Right is equal to mid minus one. You change it, no?
Let I'm just thinking about that. Which case it may be failed actually. So.
So, so what is the difference between the calculation of this bit calculation for hour and this one?
This is also fine. You are talking about
Left
line number 5.
left plus right divided by 2.
So left plus
Right divided by 2.
Same thing.
left plus right minus left. So this is also similar left.
Same thing.
Okay. So you can also write left plus right divided by 2.
Same thing, right?
Same thing. Same thing.
Yes, same thing.
So why do we have left plus right minus left divided by 2?
Yeah, Sonam, just give the answer.
Sir.
Why you write this type of
Left plus
difficult
right
expression?
minus left divided by 2, sir.
Yeah, why you written this? You can also write left plus right, no? Only. Okay, no problem. Yeah, this is also similar. Yeah.
No, not okay, sir. Still we need a.
So actually, maybe during writing this code, Sonam thinks something for this. So this is
Can we
not a.
delete the left, sir? Left plus
I
can we
just
delete?
shared for
No, not the left, the other left.
for
Okay.
discussing the codes
Alright.
and not for
No, that will be
Okay.
incorrect then.
No, take out the bracket, sir. One bracket you should take it out.
No, you are talking about you want to delete this one.
Yeah.
No, that is not correct. Then.
Okay, take out the minus
Okay,
left.
you will always get the small, only the lesser part value. So
Run the code,
index will not correct actually.
Okay.
So let me check the test case for this after checking this middle condition. This is fine P for number 1. Why the test case are small?
The test case are fine.
Sir,
Oh, sorry. I've written this code in the. Sorry, 1 second.
sir,
Yeah.
one doubt.
Once.
What? So what if means so sorry, sir.
0 plus.
Actually, I've written this code in the second problem, I think. So just. Sorry, not this. Okay, I'm writing this code in my. Okay, can you see here if I am writing this mid minus 1? One test case is failed.
Because of that,
The middle one will be failed, in which we are having peak in the middle.
If our max is coming on the middle element, then it will become failed. Okay, otherwise when we are writing in that way, so that means middle element is also coming in the next portion.
so can we correct that line number
Excuse me,
21?
sir. Sir,
Uh,
Okay, so in this case, this is the input.
sir,
hello, sir.
sir,
Uh-huh.
can I say
Yes, on.
something?
Yes, on.
On my code, sir, there is a right, left plus right minus left. No,
Uh-huh.
here left and right. Here left is equal to 0 means 0 indices is left. ऐसा ऐसा है. So we if we want to find mid, then there is a formula for every list. There is if any list there is a formula, left plus right minus left divided by 2. We find indices of mid element.
That is fine, but we can also write in that way, na? So only left plus right divided by 2.
Okay, there is several options, sir. I
Yeah,
have
there
just
are many because of that. I am not
yes.
saying anything.
Okay.
Okay, so
Yes.
this is fine. Yeah.
Okay.
So
Excuse me,
what's
sir.
run the program with
Hello,
left
sir.
plus right divided by 2?
Left plus right divided by 2.
Yeah,
Hello,
try
sir.
Still, it
once.
will work.
Hello.
Yeah, it will work, but I
This
heard
is also
I
similar
see
thing.
this many reports. That's why I was asking.
So actually, what we are doing, we are
Hello, sir.
just. 1 second. Yes, Ellen.
No,
Who's
nothing
talking?
done.
Hello, sir.
That is
Yes, Siddhant.
also
Hello, sir.
okay, but in case of there is even number of element in a list, or either even number of element in a list, or odd number of element in a list, the the formula I have written before is right for both, but left plus right by 2 is only right for even number of elements in a list. I think that.
Uh,
Actually, this formula and the previous formula is actually similar.
Yes, but this is
Okay.
for odd only, sir. Even odd only, sir.
okay. Hello,
Odd
sir.
number of elements, sir.
No, it will work in the all cases.
No, it's double divided. Can you if you is double divided in C++ we write like that. Okay.
This is
The
floor division. This is floor division.
Yeah,
Floor
this is
division
float
means it will
division.
return the integer value.
The previous one she wrote is in C++ we write like that. Yeah, this is the C plus one. It will give the there is no division in C++, right? That's why it's
Okay. You are talking about C++ then.
yeah. So here we have the double divided.
So
This
actually,
is
Python
the
we can
difference
directly
actually.
get the integer value in that way. Otherwise, in the C and C++, you can declare the integer variable to mid, and you can directly perform the division operation, and you will get the integer value in the output.
Hello, sir.
Okay, if you just declare the integer int mid, and you are performing 3 plus 7 divided by 2, definitely you will get only integer part.
Hello, sir.
Okay.
Hello. Am I audible,
Yes.
sir?
Yes, Siddhant. Go ahead.
Sir, someone, please, sir, please explain for what if the last element is the peak? How this code will work? That's I'm not getting exactly.
Actually,
For
this code will reach at the last element also. Suppose I'm just explaining the this code. Okay. So here we are comparing only this condition. L mid is greater than this. Okay. Let me just copy this code and explain this. This is handling the case actually. Okay. Suppose you have a list like 1, 3, 5, 7, 8, 9, 10. Correct? You are saying this? Okay. So in
yes,
that
sir. Yes, sir.
case, we are checking this middle element. We are getting 7. Then we are comparing mid and mid plus 1. That means this side. Okay. So if mid is greater than this mid plus 1, so this first condition is not true, then we are setting this left equal to mid plus 1. So that means mid element we are setting this side, mid plus 1.
Okay, sir. Okay,
Okay.
sir.
In this case, so now the next iteration we have, this is low. Okay, this is the low 8, and this index, so 0 1 2 3 4. So the 4 is low and high is 6. Now we will apply this 4 plus 6, okay, and divided by 2, and we are getting 5 index. So this is the 5 index. And same things using this formula, we are, what we are doing, we are doing 4 plus and right minus left, so 6 minus this. Okay, yeah, 6 minus this, so 6 minus this 4, and sorry, 6 minus 4, this is 2, and divided by 2. Okay, and we are getting same thing, so it's 1 and then 5. Okay, same index we are getting by the both formula, 5 index. So next we are comparing this element. If here this is the mid and we are comparing with this last element. Okay, now the first condition is not true, mid is not greater than mid plus 1, then we are just setting this single element. Okay, in
Yes,
this
sir.
case we are setting this low. Okay, low equal to 6 and high is also 6, so low equal to 6 and high is also 6. Now in this case 6 6, and if we are divided by 2, 6 plus 6 12 divided by 2 6, we are getting mid equal to 6. Now the next iteration, in the next case, here mid is equal to 6 is greater than mid plus 1. Okay, so why this code? Acha, okay, okay, so during if we calculate the mid by this, okay, so 6 plus right minus 0 divided by 2. Okay, so this is also 0 6. 6 is greater than mid plus 1. Hey, Sonam, so I think index error should come, no?
What, sir?
In your code.
Yes.
Okay, okay, okay. While 1 second, 1 second. Yeah. Okay, correct. So actually, this while condition is also handling this. If left is less than equal to right, then this is entering inside, and we are getting low equal to 6, high equal to 6. Both are same. So that means this while condition become false, and we are just reaching that the last condition, return L left. So that means 6 element. We are directly returning this answer.
Yeah, until left and right is equal to this loop will run.
Hmm. This code is actually handling all the cases. Okay. So we are
So
actually
what?
we are always reaching to the max element. So if max element is coming on the right side or left side or in the middle, so this code actually will reach always in that element.
So what if that bits that while condition I am just having doubt. What if left is greater than right? Then
Yeah, that index
that peak.
actually. So if left and right, so left is representing the lowest index and the right is representing the highest index in the further process. Okay, every time we are dividing the list into the half. So anytime, so during this process, we will reach only the single element. So at that time, our low and high will contain the same index. So at that time, if we have only single element to check, so that means there is no element to compare. So we can directly return that element as answer. So
So
this
when
while
there is
condition
a
actually, while condition is actually breaking that condition.
So when that peak is at the left side instead of that mid is
It's
at
still
the
same.
left side.
It's still same. uh, if any time if left and right both become equal, that means only one element is remaining. So that is only the possible answer. Okay,
Okay,
so
sir.
if the second case, you are saying that like 10 9 8 5 6 3 2 1. Okay, so here index is 0 1 2 3 4 5 6 7 7. Okay, so in the first case 0 plus 7 divided by 2 3. So we are checking this, we are comparing that if this element mid element is greater than mid plus one element. Okay, so is this condition true? If mid element is greater than mid plus 1. This condition is not true. Okay, 1 second, what is happening? if L mid, mid is 3. If mid, we are comparing this one. If mid is greater than 3, okay, then that equal to mid. Oh, sorry, I have written the wrong sequence. 6 5. So this is not the correct sequence. This one, okay. So 8 6 5. Okay, this is fine. Yeah. So in this case, when our sequence is in this decreasing sequence, so when we compare this element, mid element is greater than the mid plus 1, the first condition become true, then we are setting right equal to mid. Okay, so that means we are setting our high equal to on 3 index. So in the next iteration, low will become 0 and high will become 3. Okay, now we will calculate once again. So 0 plus 3 by 2. So 3, we will get 1 index. Okay, to check this one, 9. Now we will compare again. So 9 is greater than the right element. Yes, correct, true. Okay, so in that case, we will set our right high to mid. Okay, now high is 1 and low is 0. Low is 0, high is 1. Okay, now 0 plus 1, floor division 2, we are getting 0. So 0, and when we are comparing, now we have only 0 element. Okay, mid equal to 0. Hmm. And we are checking that mid element, are we getting the first condition true? So this mid element is greater than the mid plus 1. Yes, correct. Okay, again this condition is true. Now we will set our high equal to 0. So you can see low and high become equal. 0 high equal to 0. Now in that case, only one element is there to check. 0 0, both are pointing to the same element. So in that way, we can stop the while loop. So that condition is actually stopping the while loop if left is less than right. So this condition is now not true. So this condition will become false. We will directly return the answer L left. So okay, so this left means low. So that means 0. What is the value is at 0? That will return the output.
Yes, sir, it's working fine. I tried a
Hmm.
notebook, it's working fine.
Okay, so this is also a login code. Correct. So now this first problems took very 1.5 hours. Okay, now move to the second problem.
Sir,
Yeah, 1 second. Open that. Yes.
sir,
Yeah,
before
Prija.
second, can we discuss third?
Third. Okay, but okay. Let me open the problems. 1 second. What is it? Okay, just discuss the second problem. Then we will also
Yes,
check
sir.
the. Okay, just first the problem statement and just idea.
Sir, just we have to make a common dictionary and add elements of list one and list two, and
Common
check
dictionary.
whether
That is also okay. So here, according to the problem statement, what is the required thing? Write a Python function, find common elements in L1 and L2. Okay, that accept two integer list L1 L2 of the same length n, and return a list that contains element that are common to the both list. Okay, write a efficient solution that run in n log n time or order of n time.
Here we can use our intersection formula, sir.
No. So
Sir,
sir, instead of that,
it is
just
my
we have
first
to
day on
make
this class. Sorry for disturbing.
actually, that is built-in things. You can just try to solve using that intersection. Can you check that the test case are passes on the portal?
We can also use binary search here also.
Huh. But we are finding out the common elements. Okay. So now the two possible solution are there, and because of that, two complexity are written: n log n or order of n.
So
Okay.
order of n would be easier to solve.
So I just got your idea. So you are using the dictionary. So I think you are getting the solution in order of n time. Correct?
Yes, sir.
Okay. Yeah. Fine. Yes or no?
Sir, can you please explain in one or two line what is order of n log n or order of n? I didn't take that class, that previous class.
Okay. So actually, have you just learned this merge sort algorithm?
No,
Not
today
yet.
I'll check. Sir,
Hmm.
sorry.
Okay. So actually, this merge sort is takes log n time for the sorting the elements. Okay. And one more thing, n log n time. So actually, this Python sort, which we used in the Python, directly sort, no, dot sort, that
Okay.
also takes order of n log n times, because this Python inbuilt sort is also use this merge sort and the combination of insertion sort.
Okay,
Okay,
it is
so
just for time reference. No?
time reference. Okay, so so you can, in this problem, you can directly use the sort, built-in sort. Okay, that is
Oh,
also takes n log n time. So now this is the first thing. First, I will talk about the n log n solution. How you can.
So,
Hmm.
so previous one is log n, right?
Yeah,
Previous one.
previous one is the log n, but in that problem, we are just finding out the one element in the list. Here we have two lists, and we are finding out the common elements.
Okay, sir.
Okay, so log n is not possible here, because in some case all the elements may be common.
Here,
We have to,
here there are two lists, so that's why n
and
log n.
also lists are not sorted initially. Okay, here it is not mentioned that list is sorted. So list is totally unsorted list.
If the list were sorted, then even if there are two lists, the solution could be reached in,
Yes, you're
because we
going
are
to in the
using the
summary.
search only. So
So okay, so yeah, here there are two lists. Okay, so if we apply sorting on any one list, what is
no,
the time, what is
saying
time
if,
required?
no, I'm saying if it was sorted, then what would be have been the time complexity?
Still
Same,
okay.
same I
uh
think.
yes, same. If no, 1 second.
No, because we are adding, and you said that when you add time complexity, the
Yeah, still it is same and login, correct.
but sir, I think it should be log n only. Why it is in log n?
No. Also, just take some example.
Here two lists are there. We have to iterate two lists, right? That's why I think.
Okay, now you are saying that two lists are sorted. Okay, 1, 2, 3, 4, 5, like this. You don't know what is the common elements. Still, I'm just saying that both lists are same.
Right.
Okay, so what logic you want to apply if both lists are same to find out the common elements?
sir, if I for we can write a for loop in which we can write the thing if element present in L1
Hmm.
for
So that
element
means,
in L1, if element in L2, then
hmm,
uh, return or append something. First
okay,
of
that is
all, we
fine.
can
Then return the element.
yes,
Right.
So just tell me what could be the complexity of your approach now. You are saying that you are just reading one element from one list and
yes,
check this is exist in the second list or not using
yes,
the in operator. Okay,
Yeah.
yes,
like this one in L2.
yes.
Yes, sir.
Okay,
Yes.
okay, this is L2, this is L1. Like I'm
And
just
first
talking.
of all, we can instantiate a list like common elements or something.
No, we are finding out the common elements. So
Yes.
I'm just talking
So
about that. If according to the one who talked that if input list is sorted.
Yeah.
So according to your approach, Sonam, if you are doing thing, you know that what is the complexity of this in operation
uh,
when you write suppose like for.
Big
element.
of n.
So D in
Element in
It
yes,
L1.
D in L1. Yes.
Okay, and
If
then you are
it's
checking
if D in
ON.
L2
D
also.
N
in
square, right?
L2. Okay,
Yes.
and then
Yes.
you are appending. Suppose we are taking one another list
Yes.
L3. Okay,
Yes. Yes.
and your
Yes.
approach is look like this. So
Yes.
L3 dot append
Yes.
and D.
So
So
O
this
Yes.
of n
Exactly,
square.
sir.
okay, this is your approach.
Yes.
Now when we are checking D in, so this loop is reading element one by one from the list one, and here we are checking that if D in L2 or not. So this is in operation is actually checking that this these exist in the list 2 or not. So just think about this, how much time is required for this operation.
It is a linear program, I think.
This is the linear actually. Here it will take order of n time. Okay, because if suppose if this one element is exist at the last place, still you have to compare all element it is exist or not.
So behind this in operation, there is a code for a linear program,
Yes,
right?
definitely internally some Python provides some smaller code to do something like this append or this sort or this. There are many things it is provided, but still it is takes some time in the backend. So because of that, I've said that do not use the slicing in the binary search implementation, because our goal is to solve the binary search is log n, but slicing operation is only taking the n. Then your code will not pass the test case. Okay, so same things here. If you are using this D in L2, this is order of n operation, because to check this D exists in the L2, this comparison will be happen with the each element. Okay, inside. So here we are reading one element, one by one each element, that means n element, and for each element we are performing n order of n operation. So total n operation we have, so total n into n times
N
d
square.
square. Okay, so this is becoming n square. But here if list is sorted, so you can think about the binary search. Just read the element from the first list and just apply the binary search on the second list.
Yeah, yes.
So could
Okay,
you repeat?
to find out the
It's
common
it's a
element,
it's a
find
basic
out the,
comparison, sir.
yeah,
It's not even necessary binary search.
simple binary search. If you assume that this both lists are sorted, so you can simply read the element from one list and directly check that that element is exist in the L2 or not using the binary search. Okay, here list is sorted,
Yes, sir.
you can apply
You'll
the
get
binary
n log
search.
n
Okay, so
complexity.
that means to each element you need to need only log n time to search. So if one element you need log n time, so total n element you need n log n time to search.
So here the size of both the list should be
Yeah,
same, right?
yeah, list are same according to the problem, both sides are list are same.
But sir, in the portal test case 3, the size is different.
No. So I think you are feeling that size is different, but I think size is same. For the one second.
So for append and using these operations like insert.
Yeah, append operation. I am just actually these things is discussed in the week 3, where we are just talking about this list and things, and how much time it
So
takes
even
actually
if the
append.
lists are not the same.
So which you are saying that which test case?
So test case 3, the last one.
Actually, why you are feeling that the test not same equal length? One second. No, actually size of the both are same, but actually what happened, the in the above list some elements are 2 digit, and in the lower list, one second. Hmm.
So
You can
if that's the
write.
case,
So you can write L length of L2 on the list two. You can write
if
the
that's the case, we can choose the a minimum one because means
Actually, this is big. This is very big
It,
test case.
it is written in the problem statement itself, both the
Actually, you are feeling that this test case. Can you just check by the code? Okay, just write the
Hello,
function.
sir.
Yeah, just write the function and just print the length of the both lists.
Okay.
Hello, sir. Hello.
Yes, yes, Siddharth.
So if that's the case, if it is different, then we can choose the which is the minimum length, because if it is not in minimum length, it cannot be in maximum.
Hmm. Yeah, but this problem actually both length are same. You can see the problem. Both length are
Okay, sir.
same. Okay.
Okay, sir.
Okay. So this is the case when we are assuming that both lists are sorted, but according to the problem, lists are not sorted. Okay. Now what we can do? We can sort one list. No need to sort both lists. We can sort only one list, and we can just read the element from the unsorted list and do the same process. Okay, so suppose if you sort the second list and do not require to sort the L1 list. Okay, just read the element and check using the binary search if element is exist or not. So still n log n time is required. So total how many operations are performing? First, what we are doing, both L1 and L2 are unsorted. So we are sorting first any one of the list. It will take n log n time. You know that best algorithm of the sorting is takes n log n time. So here you can use directly the Python built-in sort. So that is also takes n log n time. Okay, so sort any one list and then do the same process. So actually this is the one steps, and second step you are just searching the element from the first list and checking that it is exist in the second element or second list or not. So that operation will also take n log n time. So here
Sorry,
two
why sorting is required? We can do
list is
without searching.
no. So here in the problem lists are not sorted.
Yes, sir. Without but search is not required. I think we take we
Hmm. But
L1 and L2. We take one element from L2 and we use the binary search and append those elements in the L3 third list and search. I don't think a search is required here. Sorting is not required here, sir.
if list is not sorted, how you are applying binary search?
Then we take suppose L1 L2 and I take one element from L2 and we search in the L1. If a element of L2 is available in L1, we'll append in the L3, do same thing, repeat the same thing for all the element of L2.
Shalendra,
Then
according to the
Yes, sir.
number of it will it will change from n log n. It will the step size will be increased.
Shalendra, one thing,
Sir.
input list are not sorted,
Right, sir.
correct? Then
Yes, sir.
how you can apply binary search if list is not sorted?
Okay.
Okay,
There are
binary
two lists
search is
L1.
binary search you can apply if list is sorted. If list is not sorted in the random order is given, then you cannot apply the binary search. Okay, so because of that you have to sort at least one list, then you can apply the binary
Okay,
search.
right. Yes, sir. Yes, sir. We have to start
Okay.
one list. Okay.
Huh.
L1, L2.
So because of that, I'm saying that first step is we will sort one list. Okay, so that step will take n log n time. Okay, suppose we sort this list L2. Then what we will do, we will just read the element from L1 which is unsorted, and we will directly check using the binary search this element is exist or not. So one
Right, sir.
element is required log n time. N element will take n log n time. Okay, so
L, right,
so
sir.
this step is required n log n. Second step for sorting, this is for sorting, and other steps will also take n log n time for the finding the common element. Okay,
Yes, sir. Right.
Sir, if you combine both, it will get bigger than an n log n, right?
no, if the two operation are performing sequentially. Okay, so this is when this first is completed, then second is starting. Okay, so that means in that case we always select the maximum. If suppose I'm just I think this is mentioned in the previous open session. If in our code there are some part, okay, so first part is complexity is order of n, okay. Second part of the complexity is like order of n square. Third part of the complexity is like n cube, okay. So this is the same one code, but we have written the complexity of part wise, okay. So this first part completed, then second part is start, then completed, then third part is start. So what would be the complexity of overall? So we always use the max of each part, n
Okay,
square, n
we
cube.
take the upper bound of the
Yes,
all.
so total overall complexity will be order of n square. Okay, so in this case, we have two parts where the one part is taking n log n time, another part is also taking n log n. So overall complexity will also be n log n. Okay, so this is the one approach. Another approach is for order of n. So I hope one have already solved using this approach, order of n,
It's a linear search.
a linear search, order of for order of n.
So linear search goes to n square.
But any data structure we can use to improve this? Okay, actually the dictionary things is not discussed yet. Okay, using dictionary, actually in week 3 this dictionary will introduce. Okay, this hashing will introduce where the searching time is actually constant. Okay, if our data is stored in the dictionary, then it takes only constant time to search an element. So if we use dictionary data structure in our in this implementation, so we can also reduce the more time, and we can write the solution in order of n time.
So for pushing all the data to the dictionary also takes some time, right?
That is order of n time, na? So suppose what you are doing, we have two lists. Okay, so L1 we have, suppose we have element like 3, 5, 4, 2, 8, 6, like, okay, and L2 we have like 4, 5, 6, 7, 1, 2, 8, 9, 10. Oh, sorry, same size. Okay, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I'm adding one more, 10, 12. Okay, so now we have two unsorted list. What we can do, we can just store one list into a dictionary. Okay, so in dictionary you have already used dictionary in the Python, lots of there are many code you have already done. Okay, so I'm talking about that dictionary. So suppose we are creating a one dictionary, and where we are just making this value as a key. Okay, so now 3, and we can just pass any value for this 3 key. Okay, so like 0, anything for the all. Okay, so similar for the 5, 0, 4, 0, and 2, 0, 8, 0, 6, 0, 10, 0, 12, 0. So this operation will take, we are creating a dictionary for list 1. Okay, so this operation will take order of n time to creating a dictionary. We are just making it all, making it the key of the dictionary for the each element. So this operation will take order of n time. What we will do next, we will just read the element from L2, and we will check this element is exist in our dictionary or not. So here, when we are reading the element, so 4 in D, so that operation actually 4 in D. This is
That
a
take
constant.
constant. Okay,
This is a
constant.
constant operation in dictionary. Okay, how this is constant? We will learn these things in the week 3 when we learn hashing. Okay.
So n
Hello,
log
sir.
n is less than O of n, right?
Not less than O of n, exactly O of n actually. Why less than O of n? Because the one operation when we are creating dictionary, it is taking order of n time. Other operation when we are reading the element from L2 and check that this element is exist in the D, so it is also taking order of 1 for each element, total n elements, so n steps. So second step will also take n step. So we have two steps, one for the dictionary creation and another for the searching. And okay, so both, what is the max of both? N.
So this
Hello,
is better
sir.
than the
Hello.
one we have tried, no?
Yes.
So this is better than the one we have tried.
Yes, yes, yes. So this is the
Hello,
benefits of the
sir.
So
dictionary.
this is
Yes.
only two through three lines of code.
Yeah, correct.
Uh,
Yes.
so what if we do means like conventional what we used to do means if the val means we will add we will add this if there is a one two number of counts the what's the complexity of that will be
Only what is the complexity for what? What you asking that?
means
Here the
no sir
complexity. If you
we
are
will
yes, yes, Ellen.
so I will tell you once.
Mhm.
So we will construct a dictionary.
Mhm.
Means using L1.
L1
Then we will
element.
add the
Yes.
if 4 is present, then we will increment the count to 1 to 2. Means just similar in
No, we are
dictionary
not
word.
incrementing the
Then how
count. Here
complex?
we are just no, we are not incrementing the count. We are finding out the common elements. Okay, so what we
No,
are
sir.
doing,
If we increment the count, what happens to complexity?
why you need to increment the count? We no need not required to
Just
increment.
For not
asking
this
this
for
for
problems, sir, for different problems.
For different problems, so if you are incrementing the count, then what is the purpose that the time is depend on what is the purpose to incrementing the count and how you want to use that count actually.
if
Okay, here,
oh,
just tell
So
me the
if
problem.
if I want to know the how much frequency that eight have, eight repeated.
So
So
it is
that's
also a order of n operation. So what you are doing, you are simply checking that the 4 is exist in the list. Yes, then you are incrementing one. So this is constant operation, incrementing the value. Okay, so for you are doing the same things for the each element, all other constants. So that means you are running one loop n time. So to creating a dictionary n operation, then just checking the count, that is also a order of n operation. Then you want to return that what is the total count of eight. So this is also a constant operation. So overall will be order of n.
But
for this kind
but
of
we are
operation,
doing an
dictionary will be
n
best
time
option.
comparison, no? We are doing it n
Huh,
time comparisons for every comparison.
no, no, no. In dictionary, it takes order of n time, order of one
Yes.
time for comparison. So this is the property of the dictionary, or you can say that this is the implement. So yeah, just after week 3 we can discuss these things. Before that, you have to learn the hashing things, how the dictionary is actually implemented,
The
and
simple thing
how dictionary
is
works.
when we take one item, one element from list two, we compare it with the dictionary keys n times, no?
Yeah,
From
because
end
of
to
that,
end,
I'm
we will be
saying
comparing it, no?
because of that I'm saying that we will learn one topic hashing in the week 3, and
Uh,
you dictionary is actually use this hashing to implement the data structure. Okay, and using the
so one last
hashing,
question.
we can search any element in constant time in dictionary.
So so there is an
Hmm.
inbuilt hashing like dictionary, right, in
Yeah,
Python.
dictionary by default inbuilt, sorry, by default implemented by the hashing concept.
Yeah, and what is the difference between implemented one and this one? We can also implement this hashing, but
Yeah, you can also implement.
yeah, what is the difference between the both when we are working with?
So if you are so dictionary, okay, so if you are just implementing some hashing things,
Yeah,
so dictionary is also similar, which you are implementing. Dictionary is just a built-in data structure which is provided by the Python, but in backend, dictionary is also using the similar concept of hashing.
okay, there is no time complexity difference.
Yes. So okay, hashing is a different concept of the to creating a data structure. So dictionary is already using that concept.
Yes, sir.
Okay, so we can directly use the dictionary if we required a constant time searching operation or insertion operation in the in our problems. Okay, no need to write every time hashing implementation by yourself. Otherwise, actually, this dictionary, this hashing. Okay, so we will discuss in the next week. We have to discuss other things also. Okay,
Yes, sir.
so just right now, just assume that this searching in the dictionary takes. So searching the key actually. Okay, not the value. Searching the key in the dictionary takes constant time. Okay, so this is key. This is value. We always search the element in the dictionary by the key, not the value. Okay, and searching the key in the dictionary takes order of
So
one time.
for value, for searching the value, how
Yeah,
much time?
searching the value you cannot search in constant time. You have to search key wise.
Yeah,
We
we have to
cannot.
compare
We could
it.
not directly search this value in the dictionary in constant time. You have to check the key wise. Then you have to compare the value. Then second key, then compare value in that way. So that way it will become order of n.
Yes.
Okay. So this is the approach for the second problem. I hope the concept is clear and nothing is new in this problem. Just sort one list and apply the binary search.
Yes, sir. Yes, sir.
Okay. Otherwise, use the dictionary and create the dictionary for one list and just use the same process without sorting any list. Just apply the searching in the dictionary. That will take constant time. Okay, so both the approaches okay. So dictionary approach will take order of n time, and sorting then binary search will take or n log n time. This problem. Okay, so moves to the
Excuse me, sir.
yes, Siddhant.
Sorry for disturbing, but I have one. What's that sorting? How will it work? Just brief it.
Okay, you have sorted the one list.
Yes, sir. Sorted one list. Then how it help in finding L2?
Huh. So okay. So once again, so L1, L2. We have two unsorted list. So just sort the one list. You can directly use L1, L2 dot sort. Okay.
Sort will get n log n. Okay.
So you can directly use this operation. It will take n log n time. Now
Yes.
after this, L2 will become sorted.
Yes.
Okay. Now what you can do, you can just read the element one by one from L1 list, which is unsorted. Okay. And
Yes.
for each element, just search in the L2 by binary search.
ಈ ಮತ್ತೆ ಮಾಡೋದಾಗ್ಲಕ್ಕ ಕರೆಕ್ಟ್ ಈಗ
Okay.
That
Means
means sir, L2 dot sort reduce the time. Reduce the time. Yes.
Yeah, you reduce your time to write the complete
If
code of
we
the sorting.
if we do not sort L2, we also find the answer, sir. But it's taking more time.
Yes. Because of that, I am saying that to achieve the n log n time complexity, you have to sort at least one list. Okay, otherwise you have to, if you are following the same approach, reading the element from L1 and searching in the L2 directly in the unsorted list, it will take n square time. Okay, so now you can apply the binary search. Now you know the binary search concept, binary search implementation. Siddhant, or who asked this question?
So
yes. I only asked.
Okay, so actually, Siddhant, so after that we can apply the binary search
This
for
is
each.
n log n. That is log n.
Yes, this sorting is n log n. After
Yes.
that process, we are reading the elements. So for we will simply write this line in that way, like for d in L1. Okay, in the
Yes.
second line we will write that binary search things. Okay, so we can directly call the function like true or false. If
So both are n log n. So it will be n log n.
hmm, yes, both are. So this part will also take n log n time. Okay, so both are n
For
log n.
n elements, it will take log n times to find
No,
that. So it
for
is
each element it will take log n time to search. So total
Yes.
have we have n elements, so total n log n time.
N log n, n log n, n log. Okay, sir. Thanks.
Yes, so n log n and n log n. So we will find return the max of this. So
Okay,
n
sir.
log n.
Thanks.
Okay. Now binary search you have already know, you can implement that.
Well, sir,
In contrast, dictionary check only log n.
No, no, order of n, not log n, order of n.
Order n. So okay, thanks.
Using dictionary, order of n.
sir, I have used the binary search
Mm-hmm.
in my code. It it is passing all the test cases in the replit, but it's not passing in the portal.
Okay, so can you just tell me replit, your replit name?
1 minute. So at 4926, the roll number is at the end is 4926.
One second. Column 2. This one 4926.
Yes, 4926.
Okay, so first A and B, you are creating this L list, B dot sort. Okay, fine. And for I in range, this low and high, you are set at this length of payload. Okay, and J is less than int length. Why this? You have
So
written.
I am limiting the number of while iterations to the square root of that length. So it should not exceed that ideally.
Why?
Because
Square root.
yeah, because we are doing binary search now. So binary, whenever we do binary search,
That will take log n.
yeah.
So
So that
log n is less than. Okay, so
correct.
so you are taking this j as a counter.
Correct.
Okay.
So
Now,
I'm just taking it as a termination condition that within that uh, within that many loops it should find the element.
okay, fine. So inside this while loop, you are calculating the middle element. Okay, made by this. If me with is greater than ai. So this is the element combination. High is equal to mid minus one. LF if mid is less than, and else is L dot append B and then break. Okay, so you are using the break loop and J. Else condition is then break. And J equal to J plus 1. So I think okay. So still this your code is not now n log n. Your code is now n square root of n.
Okay. Why? Because see, anyway, it will terminate now.
It will terminate.
Uh-huh.
But can you just compare the complexity square root of n and log n? Which one is greater? And square root of n. Can you relate this complexity? Which one is greater?
Yeah, square root of n.
Okay, so this square root is greater than. Okay, if you, anyway, if maybe you find out the answer in your code, but still your while loop will run total square root of time, square root of n time.
Mhm.
So it is increasing the time complexity of your code. Okay, so
So
square root of n is greater than the log n. Just convert your code. Just remove this condition square root of n. Yet stop this process once you find out the. So I think why you need this. If you are applying this break,
mhm. So there is a possibility that that element which I'm trying to
It's not
find
exist.
does not exist. So I will.
So you can apply the condition if lower is greater than high, is
Okay.
yeah, or low minus, sorry, high minus low is greater than zero, like this, in this way.
Mhm. Okay.
Okay, apply this type of things, but remove this square root things. Okay, this is high complexity compared to the log n.
Okay. Okay. Thank you.
Okay. Okay, now move to the third problem.
Excuse me, sir. Manhata, this said, can you see my code and tell me what error I'm making? Actually, I'm getting some error in portal.
On portal, what is your replit name?
Manhata, sir. Yeah, this one.
This one.
Yeah.
B or I equal to B1.
I think I should put -1 here. First and
No,
last.
okay, so what you are doing, you are sorting the first list, sorted B and equal to B. Okay, and C equal to this. Okay, for I in A, if I equal to B0, or why this condition you took?
Actually, I'm willing to compare first and last one. Then I started for the middle search.
First, this is
I
second, no?
think I should put in -1, B -1. I think.
Okay. So still, if this condition is true, what you are doing in the next condition, B -1 is greater than I, and this what this condition is. If last element is greater than the I, and I element is greater than the first element. First. Okay. That means if
This
I
that
value
value
is
belongs
coming
to
in
that list
between.
actually.
Okay, okay. Now you are doing the same thing. So first is 0, last is len of B. Okay, len of last equal to len of B. Okay. So it is giving any error or time
Actually,
complexity issue?
the file reading error is something I'm getting here.
One second. Yeah, you can see the it is not passing the test case on the replit also. Okay, so first thing you are taking first index and last the length of the B. Okay, and you are just assuming that last minus first is greater than 2. Why this condition? Greater than 2?
So if the list is shorter than 2, then it will be covered in the first only, first line, first if only, where I'm comparing the first and last uh, element. Line
No,
number
but
7.
no, but during this process, your list is reducing. Okay, every time you are applying the binary search, so that means your list is reducing, and during the reduction at any time, maybe you will get 2 or 3 elements. So at any time, if you are getting so this will last minus first. Suppose if last is coming 5 and first is coming at any time 3. Okay, so that means you have still 3 elements to compare: 3 index, 4 index, 5 index. But you are stopping your process by checking this condition. Okay, so 5 minus 3 is equal to 2, but when you are checking this condition it becomes false and you are stopping. Why your um, element is not possible during this part where the 3 elements you are getting? Okay, so this condition is not correct, first thing. And after that, this mid first plus last divided by 2. Okay, so I equal to mid. You are just comparing this element by mid. If this is, then returning okay LF. If I is less than mid, you are setting mid minus 1. Okay, if I is both same condition. The LF
Greater.
both condition are same, no?
Sorry, sorry.
Greater.
Greater
One
than.
sec. Okay, L is greater than and mid first equal to mid plus 1.
I've written greater than, right? Okay, you have updated. Sorry.
Yeah, I have just changed. Okay, still this condition is not true. Now just read this value as a 0. Okay. Now last minus first is greater than equal to is also possible. Yeah, equal to is also possible. Okay, now C dot append will be made LF return C. So, oh, you are also returning something? Acha, okay, so that common elements. Okay, okay, that is fine. Now still something is wrong. First, and so first you should set this as minus 1. Okay, now check what is the things is not correct. Friday, wait, total is append. B. First plus last divided by 2, I equal to made and B made. C I is less than B made. Last equal to B made minus 1 and I is greater than mu made. Okay, let me check. There is no test case.
Okay, I think after comparing the first byte, it's not jumping into loop. For loop is not getting on, I think. No, it is there.
No, why?
No, it is there, sir. Sorry.
For I in A is fine. This is, and you are comparing the element with 0, first element and last element, and then you are appending C dot append I. So this condition is become first element and last element. Okay, this is fine. But if this is not true, then you are applying binary search. Okay, if P minus 1. Okay, say minus 1 last element I is smaller than the last element and greater smaller than the first element. Oh, this condition is true.
I think this will be 11.
Okay, so now your element is smaller than the last and greater than the first. First equal to 0, last equal to ln of p minus 1, and last while last minus first. So this condition, how we need to check? So last equal to 0 plus 0. 0 is also possible. If this condition becomes 0, this will okay, they will not terminate. In this case, it will not terminate and it will run infinite. Okay, one second. Infinite 0. So So this termination condition is also actually not looking correct. Check -1. Oh, sorry. Yes, someone is there. Sonam, yes.
Sir, I have written the told before. I have told before,
Mm-hmm.
and it will working fine
For which problem?
for problem second.
Okay.
Okay, it is working fine on Replit also, and it will
Okay. So here
pass.
actually some problem is there in this code. I am just figuring out that what is the actual problem which is not written.
I
One
have not
second.
seen that, sir.
One second. Output is not coming anything. So this loop actually condition. Okay. We have to set this condition correctly. While so this last. So last will always be okay. Last minus first. First. What is the possible case? So last it is greater than 0. If any time we will minus not missed I equal to not missed. Okay, so this condition is smaller or greater than mid -1. Mid minus. Okay, so what we can write? Zero or -1. 0 -1. Start is there. Okay, one second. While loop. So that first and last we start and I'm just giving one input. So 0 and 4. Okay. So in the case of 0 and 4, what happening if this is not going outside? Test. So 3 this. Okay, so if first condition for I this is exists in the C append, in second condition if this is not true, this is completing loop. 0 and first we are getting 0 and 4. Why is it not 0 plus 4 should be again it will become 2 and 2 test case -1 first equal to mid plus 1 LF. So for this input, if you see that, if we sort this, let me check one by one. One second. Your code. So first list we are not sorting. Second list we are sorting. So 3, 7, 2, 9, 5. And another list we are sorting. Then 3, 4,
3, 4,
5,
5, 6, 7.
6, 7. Okay. Now we are searching this element. If this is exists in the first place, okay. So this is append
Yes.
in the output list 3. Now second element 7. 7 is the last element. Okay, so 7 is also append. And then 2. Okay, 2 is not first, not last, and we will apply the binary search. 0, 1, 2, 3, 4. Then 2 is coming in this range. Okay, okay. So can you see that this condition is not satisfying in this case? Which condition you have written here?
So how it's not supposed to?
Because 2 is smaller than the first element. And what condition you have written in your code? This is actually second condition if the element is coming in between first element and last element.
So that is the sorted list, no?
That is sorted list. Okay, so
It's
that
sort.
this condition is not satisfied, then this loop is okay. Okay, so this loop is still running. That means nothing is happening in this process. Okay, now
Yes.
move to the next 9. 9 is also going outside of this. So this is fine. Now 5. When we are coming on the 5, so 5 is satisfying the middle condition. Okay, so in this case 0 plus 4, and we are getting equal to 2. So 0, we are getting 2. Mid equal to
That will
2.
be equal to mid.
So this 5. Now when okay, so mid equal to 2.
Yes. Then we are appending B mid.
Okay, okay. So you have to break now. Sorry.
Oh.
Once you find this, you have to break this row. Break. Okay, if element is exist, then this loop is not terminating. Now still some test case are this. This one is passed. Break.
Understood, sir. I will find the bug. No issue.
I think some a small mistake is there in some place.
Yes, sir. Yes,
Otherwise,
sir.
you can simply write the binary search. Okay, not just use this type of condition. Logic is looking correct, but some place maybe something is missing. Okay, this
I,
is the test case. Okay. Okay, here expected output or actual output. Both are similar. 357 and 357. And why output is not? Oh, okay, this one is okay. One
what's the
second.
print?
Yeah, print statement is there. Still not passed. 20 actual output 20, 21, 23. 20, 21, 22, 23,
22,
24.
24 is good.
So 22 is not find it out in your expected output. This actual output difference is 22 and 24 is not find it out. Why? Okay, so then I have to use this condition is -1. Yeah, now passed. Okay, so actually when we are taking zero value, so at any time if element is not exist, so and we are getting the both values same, last and first same. So this difference will always come 0. Okay. or if element is not exist. Okay, so at that time, so we are reducing the value in every case. So this last equal to mid minus 1, or we are updating this value. So we have to set this according, if when we are just adding this mid equal to sorry, this last and first. So at any time we also reduce this last after getting this last equal to same index, and first equal to same index, and maybe that element is also not the required search element, then we will also reduce the last value. Then in that case we will get this minus index, difference is minus. In that case we have to stop the loop
Yes,
because element
understood.
is not exist. Okay, then it will just try to run this code.
Yes,
We
in
are
division, I think we were missing the remainder part.
hmm. So just check this code on the portal also.
Okay, sure.
Okay, it is looking fine now.
Thank you, sir.
Okay, yeah, problem number third. Anyone have solved the problem number third?
Sir, in problem number third, we don't have to care about time complexity, right?
Yes, yes. So this is simply based on the merge sort. Where is the problem statement? Okay, this is the problem. Yeah. Okay, so if you have already solved the merge sort problem, so here some card is given, shuffled card is given. There are two subordinate below you and two subordinate below them. Okay, so this is the some real time scenario is given, but if you see these things with the comparison of merge sort, the things are similar. Okay, so the job of subordinate is split the deck of the card that they received and give it into two subordinate to them. Okay, so suppose we are receiving n problems, so we will just divide that problem into two part and give that problem into two subordinate, n by 2 n by 2 like this. If they receive a deck of cards from their subordinate, they merge it in an ascending order and give it their higher level. So this first thing is the dividation things. So we are just receiving n, okay, n problems, then we are dividing n by 2 and n by 2 like in that. Okay, so n by 4, n by 4, n by 4, n by 4. Okay, so this is the first problem division process. After that, when we reached at the bottom level, then the last level will return the job after sorted the cards. Okay, after, so suppose in the last level, so according to the problem statement, if any uh, the subordinate is receiving one or two cards, it will return after sorting them. Okay, so if you see this you can see the last point. If a subordinate receive only one card, then he will directly return to the superior. Okay, if any subordinate receiving only one card, he will directly return because one is already sorted. One card is already sorted if it is not required to comparison. And the second condition from the bottom, if you see that if a subordinate receive only two card, then he or she himself herself arrange in ascending order and give back to the superior. So this is the problem similar to the merge sort. Suppose we have 8 element. Okay, so I'm just comparing this as a sorting elements. So like 8, 5, 4, 3, 7, 1, 2 and 9 like this. Okay, so this is the first n cards we have. First we will divide into two sub problems. Okay, half part here. So the half part is here like 8, 5, 4, 3. Okay, similar to here now 7, 1, 2, 9. Still the both so this is the subordinate 1, subordinate 1, subordinate 2, subordinate 3. Okay, now again he have more than 2, so it will once again divide into 2. So now 8 and 5 and 4 and 3. Okay, and here 7 and 1 and next the here is 2 and 9. Okay, so this is the next level of the division. Suppose if we have one more element like 10, so in that case we will divide in this way, like here 4 and here 5. Now in this list we will get 10, and then once again it will again divide it, and it will come like look like this, 2 and 9 and 10 only. Okay, so this is the division process. And once if any subordinate, so like this, s3, s4, s5, s6, s7, s8. Okay, so this is the subordinate name. So if any time, if any subordinate receive two or one card, if any is receiving only one card, it will directly return as it is to the superior. But if any time, if any subordinate is receiving two cards, so it will not further divided that card into a lower subordinate. It will itself sort this. Okay, so this S7 is actually sort this card, and then will return to the back to the superior. Okay, similar for this. So here S5 is receiving 7 and 1, so it will return, so after sorting 1 and 7 in this process. Okay, similar. So this is the first is the divide process, and again we are performing the merging process after sorting. Okay, similar this, it will return 5 and 8. Okay, it will return 3 and 4 to the above. Okay, so this is the similar process of the merge sort. But in the merge sort is actually we return the process once we reached at the one element. But here we are returning if we are reaching either two element or one element. If we are reaching at the one element, we will directly return one. If we are reaching until only two element, we will sort them, then we will return. Okay, so we will not further divide after that if we are receiving only two. So this is the things in the problems of now. What is the required things is asked in the problem. Okay, your task is to find how many people including you are required to sort that card and print the sorted deck of the card, and the number of people required as a tuple. Okay, so similar things, how many subordinate are required, so that counting which I have written just here. Okay, so s1, s2, s3, s4, s5, s6, like this. So 3 4, sorry, s1 2 3, sorry, this is 4, this is 5, 6, and this is 7, this is 8, this is 9. So total 9 subordinate is required to in this process, and output will be the sorted card. Okay, so sorted things. So finally we will get 1 2 3 4 5 and 7 8 9 10. So this is the sorted list, and how many total subordinate is required is 9. So this should be the answer of this program. So now how you can approach this problem. Okay, so you can see the sample. We have one unsorted list. Okay, we are assume that this is a card, and finally we are getting sorted list and how many subordinate are required. That means how many separate division happen during this process. Okay, now you can directly use, if you know the merge sort implementation, you can directly use the merge sort, but you have to modify little bit. You have to change the base case of the merge sort, and you have also used the one counter, and that counter will be the global counter. Okay, can anyone tell me any approach, anyone have already solved this?
I think we should keep on divided by 2 unless the value goes to 1, and then the number of factorial of the number of what we received in counter, that factorial plus 1.
Yeah, counter value we will increment every time when we are just calling the same recursive function. Okay, so have you written the code?
No, I was going to write actually.
Okay, okay. Anyone have any those who have written the code? Yeah, Lijes is there in the meeting. Yeah. So here you can think. Here you can see the code. One code is written by the Lijes, and that approach is actually correct. Okay, so what we will do, we will simply write the merge sort algorithm first things. Okay, this is the similar things. So same, we are using the merge concept. We are receiving two sorted list, and we are sorting. We are merging these two sorted list. Okay, and returning the final sorted list after merging. So this is the process of the merge operation, and this is the process of the merge sort actually. So this is the part when we divide the problem into two problems every times. Okay, and so you can see we are checking the length here. Now the change is that in the merge sort actually we use only this condition. First, if n equal to 1, then we will just return that element actually, that element directly. But here we have also make one more base case when we are receiving two elements. Okay, so when we are dividing the element and dividing the list into half part, at any time we will receive either two or one element. Okay, so if we are receiving one element, we will directly return that element. Okay, and then this one is actually we are returning for, because at any time when we are entering inside this subordinate. Okay, so this is the recursive function of the merge sort. Here name is subordinate, but this is actually a merge sort function. At any time when we are entering inside this function, that means one new subordinate is created. Okay, so every time this when I have just draw this diagram, you can see that s1. Okay, so when we are entering inside this s1, we are calling two times this same algorithm, same function again. So that means the same function we are calling two times recursively. That means two subordinate is required. So this is s2 and s3. Okay, once again s2 is calling two times. So once again two subordinate is required. So what we are doing, every time we are just entering inside the same recursive function. So we can use the global counter and we can increment that counter when we are inside this function. So when this function called recursively, we can increment that counter by 1 inside this. Okay, so count equal to count plus 1. We can just define one global counter out of this function and set to the 0, At any time when we are entering inside this subordinate function, we will just increment this. In this implementation, what we are doing, we are just returning one value. So this is also a correct thing. We are just returning one value as a counting. Okay, so one subordinate, as a one subordinate, we are just returning this one value. And when we have this two, okay, this, if we are receiving two elements, we are simply comparing these two elements. L0 is greater than L1, so then we are reversing that element. And so this is the part of sorting. If we are receiving two elements in the list, we are sorting in increasing order and returning. Okay, so once again we are returning the sorted list, and we are also passing one element as a one subordinate. This is the two base case. Otherwise, third is if we have more than two element in the list, so then we will divide into two for further part. Okay, so this is the division of same function again. Okay, so here, and finally we are just returning merge of two L1 L2, and S1 from the S1 is the output of this first half, S2 is the output of second half, and 1 for uh, this recursive function. Okay, this is also a one subordinate. When we are just calling two subordinate, so that means I will also counted me as a subordinate. So we are adding one more here. Okay, so what is the counting of the subordinates from the left part, and what is the counting the subordinates on the right part, and I am including myself also. So that one. Okay, or if you're not getting this things clear, then you can simply take global counter. Okay, so just take global count equal to 0, or you can directly add count equal to 0, and inside the function just increment that count equal to count plus 1, and no need to write this second parameter then. Okay, in that way you will get, so merge sort is actually sorting the list after combining the two sorted list into a one sorted list. So finally we will get the one sorted list, and this counter value is actually returning a total number of subordinate required. Okay, so I hope this is clear. If you have not learned the merge sort algorithm till now, so I think it will not be clear to you. So first you have to learn merge sort.
So why did you add one S1 plus S2 plus one?
Because of that I'm saying here we are actually just maintaining the number of subordinate, how many times we are dividing into the further. So this information we are maintaining by this second parameter S1 S2. So what happening is here, when we are dividing the problems, okay, so what we are doing, we have one list, same example I'm taking, and S1 8543 8543 and 712910 7 1 2 9 10. Okay, so this is the one input list L. Okay, we are passing, and this list we are passing into the main subordinate function. So that means the we are just considering that there is one top subordinate. Okay, so that is one, this is the one subordinate which is actually dividing this problem into two subproblem, and just passing two subproblem into two subordinate. Okay, so same things we are maintaining the counting in this recursive code. So if you see this recursive code, so we are just reading this base case. Okay, so this base case, and this is also a base case. If anytime we are receiving two, we are directly returning one, and this is the third case. So what we are doing, this is the recursive implementation actually. So we will just divide the problem into two parts first. Okay, so 8 5 4 3. So this, I'm just assuming that S. Okay, so S function we are passing this list. S means subordinate. Okay, now S again, this is the recursive call. This is the another recursive call. 8 sorry 7 1 2 9 10. Okay, this is the another recursive call. Once again, still the elements are more than two. Once again it will divide further. So S, now 8 and 5, and second is S, this 4 and 3. Okay, 4 and 3. Now still in this list the elements are more than 2, once again it will be divided. So S, first list is 7 and 1. Okay, another is 3. So 7S and list is 2, 9 and 10. Now you can see that here two elements, here we have two element, now here three element. It will further divide, recursively called, we will call. Okay, so this S, now once again 2, we are taking less element in the first list. Okay, so S, 9 and 10. Okay, so this is the division process. Okay, so this is the left recursive call, right recursive. If you just relate this into the code, so this is just a this part. If the elements are more than 2, then we are calling the same function recursively on the left part or the right part. Okay, now this function is actually returning, so this recursive call will be reached to the base case at any time. Okay, so at that time we will just also pass this one value. So this is actually representing that as a one subordinate count. So now we have reached at the base case. Okay, so all these, the lower value are actually are base case of the problem. So this have two element, 1 and 2. Now from this side it will return a sorted list, also a one value as a one count of the subordinate. Okay, so it will return a sorted list 5 and 8. Okay, and comma 1. So 1 is for one counting to the above list. Similar for this. Okay, it will return 3 and 4, one sorted list and one count for this subordinate. Okay, so this is 1, and same for the all. So 1, 7, and the another value is 1. Similar for this lower one. So here it will return 2, but one counting for one subordinate. It will return 9 and 10 and one count. Okay, now it is returning to back. So this process is returning. So where we are receiving this, so L1 we are returning this sorted list, and S1 we are getting this count. Okay, this which is 1 from each part. Okay, now what we are doing, we are simply calling the merge function L1 L2, and we are adding S1 S2 and 1. So why this S1 S2 and 1? Because we are reading S1 from this side, S1 from this, S1 equal to 1, S2 we are reading from this, S1 S2, and finally when we are merging into this list. Okay, so this is the actually merging process, or we can assume that not return back. So we can draw the lower diagram. Okay, so in that way, like, so when we are returning back, so we are merging the process. So finally after merging, so we will get this 5 8 4 3. So we will get sorted 3 4 5 8, one merge list. Okay, and S1 we are getting from one subordinate count for this, S2 1 for this, and 1 for this. Okay, so this is also a one subordinate which are receiving actually with superior. Okay, so now one from this, and 1. So total we have now 3. So in this process, so in this part we have now 3 subordinate. So this information we are getting S1 plus S2 plus this one. Okay, now we have received 3. Similar for this part, we will receive 2, 9 and 10. This is the sorted list, and 3 as a counter. Total 3 subordinate is required in this part. Okay, including this. And when we combine this also, okay, so now the value of this merging is 3. This is now S1 and this is S2 become. When we merge these two, not only this, okay, so we have one more step here. Okay,
7 and 1.
yeah, so actually this one and this one. Okay, so when we merge this,
Yeah.
okay, now this side 3 and this side 1, and 1 for superior. Okay, so when we are reaching this level one for superior, so in this case we will get the list which is actually a now 1 2 and 7 9 and 10. Okay, now total superior till now is 3 plus 1 4, and 1 is for superior, so 4 is 5. Okay, now this is not 2 level. We have received S1 3 and S2 is this one. So if we see in the above side, so we have reached till this stage. Okay, so this one and this one. Okay, this part we have reached. Now we have one more merge required into the top final one. Okay, so from this level we have 3 subordinate count. Here we have total 5 subordinate count. This one 5, and once again we are merging this one. Okay, merging this one. So this will be the final sorted list after merging. So 1 and 2 3 4 5 7 8 9 and 10, and S1 is 3. Okay, so 3 plus S2 is 5 5 plus
Plus
1 for the final superior, so 1.
yeah,
So
yes.
total 9 superior. So we
Okay.
are getting the sorted list in the output and 9 superior as a counter. Okay.
So can you share the code once, sir? I want to
But
go through it.
So,
for
but
more clarity, you can also just use the global counter in this code.
yeah, yes.
Okay, so I'm just copying this code. And 1 second. So main function. Okay, so same code I have written here. Now I can use the global counter. So like I'm using the count equal to 0. So at any time when we are entering inside this function, okay, this function, we will just increment this count plus equal to 0. Sorry, 1, and then there is no need to this, and we can remove this part. Now no need for this. Okay, and return merge, and here we'll return the count. See the function. No, here actually.
So subordinate count, why is it necessary?
Sorry.
So subordinate count, why is it necessary? The count number. We need a array, sorted array, right? Why
Yeah, this is
this?
depend on the problem statement. No? So actually problem is asking for that how many subordinate is required. Okay. So this is depends on the problem. Basically what you are learning here is algorithm. But
So this,
how,
yeah,
yes.
these problems need to solve in merge sort only. That's why they ask subordinate number.
Yes. So this is actually a real-time scenario problem which is based on the merge sort. And
Yeah.
here something else, some else extra things also required to in the answer. So that
Yes.
is actually basically how many times you call the recursive. Actually, we are counting simply recursive call of the
Yes, sir.
function.
For
So that is
quicksort, it will get different number, I think.
yeah, quicksort is different things. Yes,
Yes.
and we cannot apply quicksort here because the approach is different and of the
Yeah.
quicksort. Okay. Here we always divide into two half equal part, but quicksort we that division is happened based on the pivot element, so it will not maybe equal every time. Okay, so this approach we can use to solve this problem. I hope it is clear. This code was actually 1 second. Lee one person is there. Lee ST. Okay, so I think you can just do this problem. Now approach is clear. And next problem is pair sum. Hmm. Some initialization is happening. Okay, let me open the on the portal then. Okay, so problem number 4. Given a list of random number and another number pair sum. Okay, so here one list is given and one value is also given. Find whether there exist two numbers in the list such that their sum is equal to pair sum. Okay, so that means inside the list you have to check that if is there any number, is there any two number inside the list, actually the sum of that two number is equal to the pair sum or not.
Yes, sir. It's lead code first question to some method.
Which one?
It is lead code first question, and it's a two sum problem, right?
In lead code.
Yeah, in lead code it is the first question.
Okay, I'm not sure about that lead code. Yeah, it may be, but here yeah, that return true if there exists a pair of integer in L, otherwise false. And try to find out the solution in L log n time here. Okay, so naive approach you can apply here. Simply just
Yeah,
pick the one
so
element, then
we can uh,
yes.
we can element and subtract it by the we have to take an other variable for a and b. We have to subtract it the first element from the total of the base sum. We get the rest of the element with b. Let's say b, and we will check the subtracted element in the list.
Yeah, but what is the time complexity required then?
So it is basic n log n. It will take n log n. So when we are checking the list, we have to go with the search method, subtracted element. Yeah.
So here list is not sorted.
Yes, sir.
Okay, so because the time required is n log n.
Yes, yes.
Okay, so you can apply the sorted things. Okay, so first you saw first what you can do, you can sort the list.
Yes.
Okay, then you can pick the first element. But 1 second. Okay. Yeah,
Take a
but
variable b and sum minus first element. We will get the value of.
but every times what you have to do, suppose you are taking one list. Okay, so now after sorting you are getting list like this 1 2 3 5 8 10. Okay,
Yes.
now we are finding suppose 2. This is
There
the
is
pair. Yeah, this is the
no.
pair of,
We have to find two numbers that is equal to
yeah,
sum.
two numbers. Okay, so what we how we can do the mistakes is actually first what we will do, we will just select the first element and we will subtract from this. Okay, so
Yeah.
2 minus 1.
Yeah. We have to find
Okay,
one.
yeah, 1. We have to find another one,
Yeah.
not including this.
Yeah. While indexing, we will exit this.
But suppose if you are checking with in the lower element, then you have to remove this and you have to search from the remaining element.
Yeah. So we have to sort the.
So you cannot use the same element which you have taken as a first element. Okay, so after removing this, then you can search the subtracted number in the list, it is exist or not. Yeah, in that way you can find out the answer. Any other approach? This is the worst one things you have to apply the slicing or these things.
Window sliding method also there's window sliding.
Yes, correct. Window slide. How you are just how you can use. So
Oh,
anyway, we will sort the list first.
yeah, yes.
Okay, sorting is required. First, we will sort the list. So that is n log n time. What we can do, we can take first and last element. So like 1, 2, 3, 5, 8, and 10. Suppose we are just checking that are we getting 8 or not. So what we will do, we will just read the first element and last element, and we will add this. Okay, so we
Yes.
will add this 1 plus 10. If we are getting the greater value, then we will move this side. So this, suppose if we are taking two pointer L and R. Okay, L is pointing to the first index 0, 1, 2, 3, 4, 5. R is pointing to the last index initially, and we will just check L plus R. 1 plus 10 is greater than or equal to or less than. Three conditions are possible, and we will repeat this process until L is less than R.
Yes.
What we will do, if we are getting greater sum, okay, so then we will move right to previous element.
Yes.
Okay, if we are getting smaller value, then we will move left to one step right. So in that way, you how you can get just apply the dry run here. So for 8, okay, so 1 plus 10 is 11. So just
Yeah.
move one step R.
Yeah, yeah. This is the optimized one, sir.
Yeah,
This is.
okay, and 1 plus 8 9. Still we are getting more. So now we will just check 1 plus 8 9. Then we'll move one more right. Okay, so now R is here. Now then 1 plus 5 6. 6 is smaller than 8. Then we will move from this side L here. Now 2 plus 5 smaller than 8, we'll move here. Okay, now 3 plus 8. Okay, so now we are getting equal answers. This means this is exist. So in this way, you only need to traverse only half part or n steps. We can assume that n time. So n log n is required for sorting, and n is required for this process. So total
Yes.
will be the n log n. So okay, so any approach you can use here, either this one and either the another one, but you have to using the slicing, and you have to write the
So
big
both
code.
the cases we need a sorted array.
Yes, sorted array. Okay, and in sorted array you can apply the binary search also for the second element. If you are sorting the element, if you
Yeah.
have taken first element as a first index element as a first element, then for the remaining element you can apply the binary search because all the elements are sorted. Okay,
Yes.
so that will still the step is required n log n. Total complexity will be n log n.
When we take binary search, like you said, this 2 minus 1 might fail.
Okay, when you are
1,
using binary search.
when we are using binary search also, we are
Mhm.
looking for another element, right? One single
Yes,
another element.
you have to ignore this element which you have
Yeah.
selected.
So if there is duplicates, then it might disturb duplicates.
Yes, it might disturb. But no, you have to ignore the index actually.
Yeah. Yes.
If you have selected this zero index, then you have to ignore this zero index in the
Yeah.
process.
From either I have to come from the left side or right side.
Suppose if you are selecting this side, this as an element, then you have to ignore this three index. Otherwise, you can searching can be happen in the another remaining elements, but you cannot include this element for the sum. Okay, otherwise this approach you can follow. This is also fine. Okay, I think concept are clear for all the problems. Now you can Just try to solve here first, and after that, once you final, if you feel that answer is correct, then also check on the portal. Okay, any query, anyone?
Hello, sir.
Yes, Siddhant.
So actually, you said you will provide the solution of eighth question of last
Solution
week.
is released, I think. Have you checked the solution,
So
or
actually,
do
I
you want
don't
to
know how to check.
explanation? No, in the
Uh,
Replit team, okay, you can check the week 1. There's one more unit is released. One second. Come to the first. Okay, in the week 1, just check that there's one unit week 1 live coding solution. This is also released. You can see in your Replit team. Okay,
so
and
please, can
inside
you explain that eighth?
this eighth problem, no?
Yes.
Okay, one second. Okay, so this is the previous week, eighth problem. Okay, I'm opening the problem from not the solution also. Hmm. Still parameter is not coming correctly, so let me open here. Okay, so what problem is there? Actually, RAM has a list of A1 to AN. Okay, so these are the elements of the list. Each integer at index I denotes the money placed at that index. Do not following the operation exactly. Okay, money placed at index I. He can do the following operation exactly one. So what is the operation? Pick a sub-segment of the list and cyclically rotate it in the clockwise direction by any amount of time. So pick integer L and R such that, so this some constant are given, and rotate the list in that way in the clockwise direction by any amount. Ram wants the maximum amount of money by performing this particular operation exactly one. After performing the operation, Ram will collect an minus a1 amount, okay, of the money, and that should be the maximum actually. How we can achieve this? Okay, so first I just explain the problem by this input. One second. Let me- So in the problem statement, you are given a one list, okay, this type of list. What we are calculating is, so this is the index. To solve the problem, we will just consider as a 0, 1, 2, 3, 4. But in the problem statement, it is generalized in and 1, 2, 3, 4, 5 to n. Okay. So what is given that this an minus a0. Okay, so sorry, not an and minus a1. Here we can just assume that a4 minus a0. That value should be maximum. Okay, and we can follow some operations. So what we can do, we can just pick any sub part of the list, okay, and we can just clockwise the rotate the elements clockwise. So that means we can just suppose in this list 1 9 8 4 6. Initially for this list what we are getting 6 minus 1, which is 5. Okay, but what we can what operation we can perform, we can select sub list. Like suppose we are selecting this sub part, okay, now we can clockwise rotate this list any number of times. So suppose if I rotate this one time, so 1 9 8, and it will become 6 4. Okay, if I rotate this part clockwise. So now this element is coming at the last position. This is at the first. So 4 minus 1 will become 3. Okay. Now this is the one possibility. And same things, if the input list is given, I can select this part. Okay. And I can rotate this any number of times. So what we can do, after rotating, we will get, so this is the here. Okay. So 1, 9, and I rotate this two times. Okay. So it will become 8 here and 6 here and 4 here. Okay. After rotating two times this part. Now the difference is 8 minus 1 is equal to 7. Okay, so in that way, how we can decide the rotation, the substring part, so we will get this difference maximum. Suppose the one more steps. Okay, so suppose I select this part. Okay, I support this part to rotate, and I rotate this part three times. Okay, so we will get 1, and then 9 here. So 9 will reach here, and then 6. Yeah, 6, and then 4, then 8. And that was okay. 6. Okay, so sorry, 6 and okay, 6, 9, 6, then 4, and then 8. Okay, fine. So after some three rotations, so we are getting this list: 1, 8, 4, 6, 9. Now last element is 9 and first element is 1. So 9 minus 1 is 8. So now this is the best solution, 8, after doing this process. So how we can achieve this answer? So this is the things according to the problem statement. We need to find out the maximum difference from last element to the first element. And we can rotate something in this way. So according to the problem, this is the things we have to apply. But how we can figure out the logic for this without rotating or without applying the all possible case, how we can figure out the logic to solve this problem? So this is actually not a easy problem. This is actually competitive problem. Last two problems are actually challenging problems in the week one we have given. So here you no need to find out the way to just rotate the things and apply the finding out the all possibility of the rotations. You have to figure out the way to get the answer. So how you can find out? So what you can do, suppose if any input list is given, so this the same list is given. So 198, 198. This is the main input, 198, 46. Okay, 46. So to finding out the maximum answer, okay, maximum difference from last element to first element, last value should be the maximum, okay, and first value should be the minimum of the list. Okay, so can we arrange our element in that way? So this difference will be the maximum actually. So in that way, first things what you can do, so now you can think about that which element can be come at the last place after rotations. So first things you can calculate the answer for first possibility. So this okay, no, not first possibility. So things is that this first place value should be the minimum and last place value should be the maximum. This is our goal to get the answer. Now if you are assuming that first value is the minimum, okay, now you can find out the maximum value from this part. Just find out the maximum value from the, don't no need to touch this value, first value. Okay, just you are assuming that first value is minimum. Just figure out that what is the maximum value in this part. Any if maximum value in this part can be easily comes at the last position after some rotation. Okay, suppose the maximum value is this 9. Okay, so we can shift this value 9 at the last place after some rotations of the clockwise of this part. Okay, 9, 8, 4, 6. So anyway we can shifted this maximum value to the last place. after some rotations of the clockwise for this part only. Okay, suppose in the another example, like this is 1 and our elements are like this, 4 and 8 and 9 and 6. Okay, still if we are assuming that this is a minimum, then we can find out the maximum. So maximum is here. Okay, this value can be shifted to the last place. If we select this substring 9 and 6, then we can simply rotate one time and then it will become at the last place. So without rotating anything, if we are assuming that this value is the minimum and just finding out the maximum on the remaining part. So this is the one possibility of the answer. So suppose I am assuming this first case. Okay, so L1, we are just finding out the max of L, and so this is the first index and the after the remaining list. Okay, so I'm just mentioning the slicing things. So L, all the elements after removing this first element, what is the max value of this? Minus L0. Okay, so we can directly calculate this one possibility, one value. Okay, and another possibility is that similar things, we can assume that last element is the maximum and we want to shift first element as a minimum. Okay, so the just opposite things, we have suppose one example like 6 8 2 1 9 5 and 10. Okay, and we are assuming that this is the we just assume that this is the maximum element, and can we shift the minimum element which is coming in the remaining part to the first place? Yes, we can shift. Okay, so suppose one is the this is the minimum, so we can just select this of strings and we can rotate one time, so this one will come at this place. Okay, so that means we can find if this smallest element is coming at any place, we can select the first element to that place and we can rotate one time. Okay, so that smallest element will shift it to the first place. So we can directly calculate the second possibility answer, which is L of -1. This is the last element minus minimum of L and last element. Okay, so this is -1. Okay. Okay, so this is second possibility. Another possibility is there, one more there. So if minimum and maximum both are coming in between. Okay, so what is the possibility to shift all these middle elements? So suppose if I am having element this like 1 3 4, not 1 3 4, like 7 3 4 and 12 and like 1 6 8. Okay, suppose we have this type of situation. Now we have already select two situation. Now if we rotate any substrings in this list, so what is the possibility of the element which can come on the last and first? So only the adjacent element can come on the first and last place. So suppose these two elements are we want to shift, we want to rotate this list uh, any number of times. So only this four, if we rotate complete list. Okay, so we are rotating this complete list in the clockwise direction. Okay, so in that case, this okay, so not this part. Okay, so in this case, suppose if we select this pair. Okay, now after rotating this list, complete list, I'm talking about complete list. Okay, after rotating this list clockwise, so after 3 steps, okay, so this 8 will move here. Okay, now this shift here. Now 6 will become a last element. Now this 6 will be move here and 1 will be reached at the last place. Now once again when we apply the one more clockwise rotation, then 1 will be reach at the first position and 12 will reach at the last position. So after 3 rotation, our list will look like this: 8 6 and 1 and then 7, 3, 4, 12. So after three rotation of the complete list, our list will become this in this way. Okay, so 12 and 1. So now 12 minus 1 is 11. So this will become the answer for this example. So in this
In
case,
this
hmm,
in this
so
case, we are considering whole list as a sub array.
yeah, whole list, yeah. So but no need to require
Okay.
identify this thing information which how many rotation we need to apply. Just for each adjacent value, find out the difference. Okay, for each adjacent value. Okay, if value which are coming, suppose if we are taking I index, okay, and we are taking I index for checking the things. So only the we have the benefits if the I and I plus 1, if we are checking I index and I plus 1 index, if this value is smaller than the I plus 1 value, that means this value can be come at the first index and this value can come at the last index after some rotations of the list. So we will check only these things if ith element is greater than the ith plus 1 element, then we will find out the difference. Okay, so we will check the difference for each pair, or you also no need to check this condition also. If I plus 1 is smaller than I, just find out the difference of each element. Okay, so 7 minus 3, what is the difference? 4. Now 3 minus 4, 3 minus 4 difference is minus 1. 4 minus 12, so 4 minus 12 difference is minus 8. Now 12 minus 1, 12 minus 1 is 11, and 1 minus 6, 1 minus 6 is minus 5, and 6 minus 8, 6 minus 8 is this is minus 2. So all these difference just return the this 11 max of. So three possibility you have to check. First L1, I'm just taking this P1 and P2 second possibility, and this is the third possibility. Just we will compute the difference between each pair of the list and we will return the max. So this is the third possible answer. Okay, out of this this is P3 is this max of all this part. Okay, all this difference. And out of these all three possible case, P1, P2 and P3, just return the max of P1 and P2 and P3. So which one is the maximum? That would be the answer for this problem. Okay, so according to the problem statement, this information is given, you can rotate only in that way. So we can just figure out the first case. If this is minimum, then we can shift it the maximum element to the last position from this side. Okay, if this element is maximum, then we can shift it to the minimum element at the first place after some rotation, and otherwise we can shift it to the each adjacent element at the first and last position. So we will calculate the difference for each adjacent 7, 3, 3, 4, 4, 4, and we will return the maximum. Okay, so in that way, after that finding out the all three possible answer, we will return the maximum. So that will become the answer for this problem. Okay, so this is the logical things for this problem. So, and this is actually challenging problem, so don't worry about this. This is given just as a challenging problem. Okay, I hope this is clear. The now solution you can also see which we have released. The same things we are doing in the solution. Let me check the solution file. Okay, I think the solution is also released on the portal, so you can go to the supplementary content and see the live coding solution. And Here can click and download. So okay. So you can see that what we are doing, we are just calculating the first possible answer 1, answer 2, another possibility, and for answer 3, we are just running a loop in the list, and we are calculating the difference between the second last for the each index I. We are calculating the difference between each pair, okay, and returning the max, okay. So that will become answer 3, and finally that we are returning the max of answer 1, answer 2, answer 3. That will become the answer for this. Okay. Any query, any other one? Okay, I hope all the things are clear. Any query from anyone?
So everything is clear.
Okay, okay, fine. So just solve all the problems on the portal also, and we will meet in the next week.
Okay.
Okay.
Thank
Thanks.
you, sir.
Yeah. Thanks, everyone. Good night.
Thank you so much, sir, for giving your time.
Okay, okay. Yeah, Ravikant.
Good night, sir.
Good night. Yeah, good night, everyone.